Hello everyone, and welcome to this workshop. Or in fact, this is a multi-part workshop, including one part that is about open source tools for publishing, and also another part which is dedicated to AI, which probably is also quite interesting nowadays. So this is a kind of whole day event. We plan activities up to about 3 p.m., somewhere there, and we'll try to keep schedule. Hopefully everything goes smoothly from here on, and yeah. So the event itself is organized by IEEE Young Professionals Estonia section. So you can see here this nice roll-up. So if you want to learn more about us and about our activities, I will also speak a little bit about that in the presentation that you are about to see in the welcoming words, but so far you can also browse if you want. You can just check it out. Okay, so a few words actually about young professionals, what we do, what our main activities are. So myself, I'm Aleksei. I'm a senior research scientist here in TalTech University with a fair amount of work put behind throughout the years in this field. Head of XR lab as well, senior member of IEEE, and as it happens at the moment, I'm also chair of IEEE Estonia Young Professionals Affinity Group. And here also you can see my good colleague Sreenath, who is now Secretary of Young Professionals. He's done a major part of the work in organizing this event, so that's very good. And you can reach out to me if you want via this contact here. So a few words about IEEE as well. It's an international organization, so it's basically Institute of Electrical and Electronics Engineers, established in the US. And we have upwards of 400,000 members all across the world. And Estonia belongs to, basically the organization is divided into several regions, and Estonia falls into region 8, R8 shortly. So you may know IEEE by some of the activities, some of the standards that they have actually provided, such as the USB standard and Wi-Fi standards as well. So usually this is how people know them. But as you can see, we also have other kinds of activities that we are organizing, such as this event, for example. So we're kind of doing a lot of things. It's a non-profit organization, so all of this is voluntary work, and so here we are. So specifically about Estonia, we have here, we've had quite a long run with these different things throughout the years. So here on this specific picture you can see something that is called the Reimagine Lab, which I was for a long time head of. Virtual reality lab, so this comes from one of the workshops that we have organized there. So yeah, young professionals is basically connecting all young professionals, and young is a kind of relative term, so we have people over 40, over 50 in the organization as well. It's fine, as long as you feel you belong, then you can definitely join. So previously we've organized larger scale events, so we consider this one today a kind of large scale event because it was initially intended for 50 participants. We have a few less at the moment, but I'm pretty sure that some people will actually come for the panel as well, which comes in the later part of the day. So but we have also done these kind of large-scale events, and one of them, which kind of tends to become a series, is this academia to industry event. So we had a kickoff seminar, I think in 2018, somewhere there, and we had invited representatives of several companies to speak about what they're looking for in terms of student graduates, what kind of skills they're looking for, and so forth. And it actually helped a few people secure some job positions somewhere, so I think it was quite successful. this kickoff event. So last year we also had a follow-up to that. So again, it's kind of becoming a series. So last year looked something like this, same room, except the other projector was working. I'm told that it's broken right now. Well, you know, maybe next year none of them work and we just have to use the whiteboard, but it's fine. So yeah, quite a successful event as well. And other regular events, something that we do here as well on the under the umbrella of Unreal Talent. So this is we have a series of events there, which is called Young Professionals in Game Development. And we've had many different meetups with these groups, also in the VR lab, which doesn't exist anymore, but it was really cool when it did. So we had some really nice exchanges there. Okay, and just as one final note before we get to the meat of it, is again, if you visit our website, you can see it here. So IEEE Young Professionals Estonia. So let me also once again introduce the leadership team as well. Myself, I'm here. We also have anyone who is not here, I guess, but he's vice chair, and also Sreenath as secretary. And this is kind of a very powerful team, since it seems that now we can organize even more events to kind of benefit everyone who wants to participate. Yeah, so also here you can see the events hosted since 2020. As you can imagine, it was very difficult to host events in 2020 and until about 2022, but somehow we managed. Mostly those were either online events or webinars or stuff like that, but we've also done this interesting stuff in the form of so I have to click several times to actually get to those. Let me see, here we are. So these IEEE Connecting Experts, which is a program we can also look up. I think it stopped at the moment, but during this 2020 and beyond, people were quite active there, and quite a few interesting talks on different aspects of industry can also be gathered from there. So we have participated, I think, 3 times in this one. Okay, so let us then move on. So thanks for paying attention to all this stuff, and I think we can now get back to or get started with the actual workshop. Okay. Oops. Somehow from the middle, too early for that. Let's go here. But before we get started, also a few words about housekeeping. So here on the whiteboard, you can see that coffee breaks and lunch are upstairs. So in the same place where you have already seen. So yeah, right now the plan is that I will do this workshop. Then there's a lunch break, and then we return with another class or workshop, which will be 45 minutes. This one is the toughest part. It's 2 hours, almost. So let's get through it. Hopefully you learn something interesting and will be much, or maybe more productive in writing, and also enjoy it more. Because I know a lot of you are using already this LaTeX, but there are also tools out there that can make it even a more enjoyable experience for you. So let's get started. For this I will sit down, since I will be drawing a little bit on the screen as well, giving some insights into what you can expect. So this workshop contains, again, 2 parts. First one is we're just going to go through a set of slides, and then finally we get to, you know, like the practical aspect as well, where we're going to actually do some hands-on stuff. So I've sent an email containing a few links yesterday to all the registered participants who registered up until that point. So if you've registered later, you might not have received it, but It's here, so cis.ttu.ee/lex21. So let me just repeat that on the whiteboard. So from there you can grab links to software that will be used in the practical hands-on part of the workshop, and you can even, if you don't have it installed at the moment, you can even try to install all of that stuff right now. While I'm talking in the first part, you can probably make it. Right, so again okay, maybe an important slide, but it's a bit outdated as well. So how many years I was in research? Many years, basically. Okay. The idea of this presentation is to give a brief overview of what TalTech is, a brief introduction to LaTeX language. Some of you already know it, some of you already use it, but just bear with me here. Some important considerations, other useful software, and references. So let's get started. First let's set something straight. For instance, how you pronounce this tech. So you pronounce it as tech. A lot of people tend to pronounce it as tex, and then also the other one is LaTeX, which it is not. So LaTeX is a material, LaTeX is a typesetting program, and the reason is that this X is not actually an X, it's chi, it's Greek letter, which is should be pronounced as k. So it's tech and LaTeX. Just getting something straight here. But the point is that tech is very sophisticated. It was actually developed by Donald Knuth. I will mention him in the following slides. So if you know who that is, he's the author of a multi-volume book called The Art of Computer Programming, which is like considered a kind of Bible for computer scientists. It contains like something like this thick mathematical introduction, which is required to digest the rest of the book, and it's probably best used as a kind of reference material. But you can imagine that a person like this, if he writes some sort of program, it will probably be quite complicated to use. So, and the tech, in that sense, it is quite difficult to comprehend how to write specifically these expressions that will result in some beautiful output. The benefit, though, is that tech, being as sophisticated as it is, it gives you like complete control over the typesetting quality. So inevitably, if you work with the system long enough, you will kind of get, you will feel the need to create some sort of new template or change some template around, stuff like that. And this is where you have to actually do a deep dive into tech, and it's a bit mind-boggling, especially if you're not a coder or programmer. So it's best to ask your colleague who is actually doing something like that, maybe. But yeah, it gives you full control, and it gives you a complete set of tools to create whatever you want in type. And by type here, I mean typeset, right? So whatever is written on the page, in this day and age, it's more kind of electronic format, of course, but it doesn't matter. Point is that it gives you that ability. And because of this complexity, LaTeX was actually invented by Leslie Lamport, which is a set of macros, which makes it more, makes tech more as a kind of template or markup language, such as HTML, for example. So if you've ever created a simple website using HTML, LaTeX is basically similar in functionality because it doesn't require you to actually deep dive into tech. You can just use simple commands, simple layouts, stuff like that, and it will still work very well. Right, so it's a very, very brief introduction here. So a bit of motivation as well. This slide is primarily intended for people who are maybe not moving away from ecosystems like Microsoft Office or OpenOffice or something like this. I mean, we're not really saying that you cannot use a certain certain ecosystem and just use this one, for example. So, but you can definitely achieve improvements in productivity in terms of using LaTeX, and also create really beautiful documents which are professionally crafted because of all of the knowledge of typesetting that actually went into developing of these systems. Outstanding quality of typesetting. LaTeX specifically takes care of the logical structure of the document, so the idea there is more on I mean, the concept of what you see is what you get with something like Microsoft Word is one thing, but the other thing is what you see is what you mean, which is the concept of this typesetting system, which is offered by LaTeX and LaTeX specifically. Also, there's like packages for LaTeX, which allow you to actually typeset almost anything. Like there's a package for music engraving, for instance, so you can type orchestral scores with this thing, which is very cool. Also packages for drawing diagrams of arbitrary complexity and stuff like that. So it's actually really powerful stuff in there. And of course, the reason why we talk about these guys today is because these are open source, and this is the primary one of the primary topics of today's workshop, is that we consider like this open source software, right? So, and of course, already in the email that you might have received, I mentioned overleaf. We can discuss that at the end, or maybe during the workshop as well. So why do we need to learn all of this stuff if we have overleaf, right? That makes collaboration easy, and so on and so on. So we'll get to that. So that's basically the motivation. Also, of course, there are obstacles in adopting LaTeX. Leaving the comfort zone is the most important one, I think. Like if from school throughout to the university and beyond you were taught to use stuff like Microsoft Word, then you gladly stick to that and just continue using it, and you don't want to move into this risky zone of using LaTeX and stuff like that. But trust me, I was there as well. When I was finishing my bachelor studies, I wrote my thesis in Microsoft Word. It was tedious because I had to move stuff around, you know, like stuff gets in your way more. You try to write, but you need to take care of layout and stuff like this. Maybe it's because, of course, one of my colleagues would say, it's because you don't know how to use Microsoft Word. Okay, let's leave it there. But with LaTeX, you don't have to worry about that. Well, you do, but in a limited quantity, let's say. So it's definitely gives you this productivity boost that you don't have to worry about certain things, and you can easily, once you learn how to do it, you don't really need to think about it too much. You just know, okay, these figures, these tables will go on a single page, let me configure that, and it's a couple of clicks, done, and so on. So it's very easy and intuitive once you get there. But in order to get there, you need to also go through this learning curve, obviously, which is your kind of, let's say, payment to be more productive. But it's like the case for any kind of new stuff that you may want to learn. Then there is also one major quirk, which is the aging nature of the original implementation of both LaTeX, which is used for typesetting, and BibTeX, which is used for typesetting and managing bibliographies. So it's a kind of a problem, surely, but at the same time, right now we are almost at the stage where in also LaTeX, for example, the default character set will be switched finally to UTF or Unicode, which means that you can almost forget about any such issues. So you will then be able to use also in with LaTeX instead of BibTeX, formatting the bibliographies with Unicode, and then it just becomes no longer is a problem. But you do have to think about it because, for example, like in case of the default implementation of BibTeX, it supports only 8-bit representations of characters. So in order to typeset something like this, right, you would need to type in your code a construction like this. So it's a backslash, then quotation marks, then A. And then this will render finally you this character. Whereas with Unicode, you just type your desired character and that's it. So you don't need to do anything else. So that's what I mean here with the aging nature of these systems. Right, so before we get to mentioning our wonderful developers who made the system possible, let me also give you a bit of more motivation, since I know maybe there will be questions. So let me just answer some of them immediately. And also I will show you how LaTeX looks like if you have never seen it before. So here I have this huge file set. I will explain what it is in a second. So the idea is that in one of the projects that we were doing, it was a kind of research and development project, we needed to create a document. But this document was envisioned as a kind of living document, meaning that it should be possible to update this document at any time. But given the fact that if you, let's say you have a Word file, so then people directly edit that file, and because there were 20 or so partners in this project, the editorial work on this file would become a nightmare. So you have to constantly monitor the quality of the document. So if somebody adds something, everything goes astray and you have to fix it. It's a nightmare basically. So in order to make it much more simple for other people to contribute, what we've done is we created an online system which was used in such a way that people would directly insert pieces of information in a familiar way. So there's a kind of database, an online database, where people would plug in information into. And then what would happen is when the document needed to be compiled, that information was pulled from there. And then we kind of put it into this document and finally compiled it. So, and I used LaTeX to create the template, which looks something like this. Let me open it. And I will give you a brief tour before we actually get started with that. So with LaTeX, you can do pretty much anything advanced as well. Like, for example, there's a title page that I don't want to format with LaTeX due to various elements and stuff like that. So you can just plug in a PDF page into LaTeX and it will just be there, and that's it. So that's the first title page, and let's see, table of contents here as well. It's like when you click on it, you actually get the outline here, but it doesn't show directly in here. It's just a placeholder. So whenever you generate a document, what will happen is at that place, the table of contents will be inserted. And then you have, what is this? This would be, oh my God. Painful. So this is part, I can see it, but it's very difficult to see from here. Look at this. Scaling issues. But yeah, so this is a part, and then there will be text, and this is LaTeX under the hood, but you don't have to know it. You don't have to see, like codes and stuff like that. What you need to do is you type. You just start typing away, and that's it. And inserting some evil red text like here may be sometimes required, but for let's say a beginner user, this is not needed. This is a bit more of an advanced example, to be honest, because it did use a lot of these various tricks that are more relevant in advanced usage. So yeah, okay, and then another part, and you see it's all basically text. Then okay, here we have a figure float, which is a container which contains a figure. So it's nicely displayed here. You can collapse it if you don't want to see the figure. You can also change the size. Okay, I will probably have to change the scaling for the later part of the workshop, because otherwise I cannot tell you what what to do here. But okay, you can change how the image is displayed in here without affecting the final output as well. So all of this stuff, very easy. I don't think I have tables in here, so I cannot show you this right now, but we will get to the workshop. But the point is, so all of this stuff, this template is created with LaTeX, and later what happens is there are template parts like this, and when we need to create this additional stuff that the users have supplied via other means, what happens is you just compile that into LaTeX code, replace the placeholder in the LaTeX template, and then what you get is essentially this document over here. So I have by default set it so that the last open page will be open for me in Reader. But yeah, so here's the template part. Look at how nicely it looks. Everything is typeset professionally. Here's the table of contents that I mentioned, which is generated automatically. Looks nice and actually works. So you can click on here, for example, room scale. Here we are. Takes you directly to the section in question. Then you have all of this stuff. The images are inserted as well. Then you have some additional stuff and so on. But then the part that actually came with we can actually use bookmarks, which are also inserted automatically. So we can just navigate the document here. We can insert stuff like this, as I showed before. And it's all like typeset really nicely. And this is the part that's actually auto-generated. So in order to answer the question of this overleaf, one answer, can you do this with overleaf? The answer is no, because you would have to automate this on the end device, which overleaf does not allow to do. Well, I mean, you can submit all of this code into overleaf, but imagine that this is how many pages in this document. You cannot see it right now. Let's just go here. Well, okay, quite a lot of pages. Okay, 229, so about 300 pages. So imagine how long it would take to compile an overleaf. Forget it. Use offline method. Just run it locally or on a server somewhere there. So this is one use case which I really like, because it was really easy to kind of put people together and to work on this problem using an online database, and then just pull the information from there and automate all of this stuff into a nicely looking document. So honorable mentions, so Origins of Tech, Donald Knuth, who I've already mentioned. So the author of The Art of Computer Programming, obviously. He's a big fan of the number pi. Huge fan. You can actually look him up, and the first thing I think you will find is his class or lecture or something like this on the number pi and what you can derive from it. I think he's now 86 years old, but he's still active, and really inspiring guy. But the point is that as he was writing this Art of Computer Programming book, he was handed galley proofs of that book, and he was not content. He said, okay, probably I can do better. And then he invented tech. So if nobody else can do it yourself. This is the paradigm here. And so he did, and tech was then born, and people, of course, picked it up, started using it, but found it to be quite difficult to use, especially like the entry level was really difficult. So then came Leslie Lamport, and he developed LaTeX, which is a set of macros which allow you to work with LaTeX far more easily, or with tech more easily, using LaTeX expressions. So the main idea of LaTeX, as stated here, is that the authors should be able to focus on the content of what they are writing without being distracted by the visual representation. That's the gist of it. And I like this very much. Okay, so how is LaTeX used? Obviously, books. LaTeX is used for books, and recently, well, not recently actually, it was 2017, I believe. So I had worked on a manuscript which was submitted to Springer, and then they used the kind of online system for editing it, and it was also completely LaTeX based. And the workflow there, the pipeline was just excellent. It was so easy to use, like from the beginning. So, and it was for a book, so it was really cool that they, it was not overleaf, okay? It was some in-house system or something like this, but really cool. Of course, manuscripts, this is primarily what we use LaTeX for, using overleaf, using licks, and all those nice things. Presentation slides, and this presentation was actually prepared with TalTech, specifically with licks, actually. Web publications, something that I do not recommend this stuff for, so don't use it, because you have seen maybe a previous presentation where I talked about the unprofessionals. That was created using Reveal.js. So if you want web publications, if you want web presentations or stuff like that, use that instead. It supports LaTeX in terms of math, so you can still use like mathematical typesetting there, but it's much more easy and flexible than using LaTeX for web stuff. For presentations, it's perfectly fine. There's the Beamer class, the Power.class, class, which is this one, and you can still use it, but web publications, please don't. Right, so let's have a brief introduction to LaTeX as well, to those who may not be familiar with it. So I will just digest this specific example. So a lot of people are put off by the fact that you're writing code in order to get a document, which obviously is distracting a lot of people, but only if, I mean, with licks it's not a problem at all, because all of this stuff will be taken care of for you. But with pure LaTeX, yeah, people are put off, of course, by it. But you can think about it rather than coding, more of doing kind of markup. It's a bit, then makes your life easier. So, and in terms of markup, what is here, like for example, the first statement here, which is document class, article. So, I mean, it's simple to understand, right? So we have a document class, which is article, and then 12 points here is an option, meaning that we will typeset the article with the base size of the font, 12 points. A lot of people don't want to think about it, but you do change the size of font in Microsoft Word, for example, right? So that's exactly what is going on here. You're setting the base size, which will then be used to determine the sizes of all the other stuff, like section titles and stuff like that. So this is why it is important. And also, based on this first first command, we can see the syntax of the language, which is basically you use backslashes. So backslash this, backslash that. So in the first case, it's backslash document class. Then there's some command. Then there's options, like this. And then there's actually the main content, which in this case is also an option, which is article. So the main option is article, but this specifies some additional non-mandatory parameters, like in this case 12 points, because it also has a default, which I believe is 10 points. Okay, so simple as that. You just need to locate backslash on your keyboard. And also for licks, you will still be using backslash quite a bit, especially for math expressions if you're doing math stuff, because it's much faster to just type the equation. It will be displayed for you, but when you're typing it, it's much faster to type backslash sum, for example, than to start looking for this command, which by the way typesets this guy, to look for this command inside the palette of mathematical expressions, which is also there. So you will be able to use that as well. But yeah, so backslash is your friend with LaTeX. What happens next is this guy here, which is which says use package AMS math. So this is basically, if you're familiar with coding, something like Python, this is your import statement, right? So this is, oops, or was it correct? Import. Okay, so this is the import, or the equivalent of the import statement. It means let's use package AMS math in the remaining document. Import, or of course, if you're familiar with stuff like C# or C or PHP, whatever. So it's kind of use this context. So this is why use is here. But yeah, what it does, essentially, it imports this package, which in this case is AMS math, and I think it's necessary for the environment, which we will get to in a second, which is the align environment. So what it contains, this package contains a lot of stuff for mathematics, for typesetting mathematics. AMS stands for American Mathematics Association or something like, or a society or something like that. So it contains all of that nice stuff. Okay, so we're using the package, and then what happens next is there's also title, which defines the title of our article, and then the date. So all of this stuff that you can see in front here is called the preamble. So all of this stuff up to here is called preamble. The idea of preamble is just to configure the document so that we can then use anything, any of those configurations inside of the main document, like packages, some meta information like the title, and so on. And then we actually begin the document here, so this is where the actual content starts, and you cannot import packages here anymore. So when we begin the document, you can no longer do this guy over here, which is logical, yes? So the first thing we do here is make title. So this is what typesets the title of the article for us. And once we do that, we're free to do whatever we want. We can create sections, subsections, and so on, insert structural elements, insert math, such as this one. So all of this stuff will then be in the main content or the main text of the document. And just make sure that I'm going with time here. So yeah, now, then what you can see here is this is where the actual text starts with this \LaTeX, which is also a command, which will typeset the LaTeX logo, something like this. So later on we will see it. And you just start typing, basically. There are some commands that you insert here and there, but the essential thing is that you just type text. If you need an equation, of course, it's more difficult, but in general, it's just you typing the text. If you want to insert a comment or remove a part of the text, which is usual, like let's say you submit a paper into, I don't know, conference or journal or something like that, and then you receive a comment, please, maybe there's a page limit, so please reduce the introduction, let's say. You can do that, of course. You can just remove the text, but you can also comment it out, and for this you would be using you would be using comments, which start with this % here. So you type something like that, and you still keep the content if you want to use it later, but it will not show up in the output. So this is really convenient. So you don't lose anything. If you are a doctoral student, let's say, and you're working on your thesis, and you have these papers where you had to remove some stuff from, great. You can return to the commented out stuff and you can put it in the thesis because there are no limitations there, let's say. So very convenient. You can do the same with LaTeX, of course. We will get to that. Then what we have next is something that is called an environment. So this guy. And just like document, which is also a huge environment, so it starts with begin document and ends with end document. So it's also an environment, and inside this environment there could be nested environments, like for example is begin align and end align. So align is a mathematical structure, so it will be used to typeset the equation over here, which of course you can already see some really popular science stuff like E equals mc squared, and something else over here. I mean, it might look, for somebody who's just starting out with LaTeX and mathematical typesetting, this may look quite comprehensive. There's a lot of symbols. It's not really clear where anything goes, like what is this frac, what is this SQRT, if you're completely unfamiliar with this stuff. But eventually, as you progress with your LaTeX knowledge, you can just, like in the matrix, you look at this and you can see actually the equations already in your head. You don't have to do that with LaTeX. It will just typeset it for you. That's the power of LaTeX. But once you get experience points, this is what will happen. And then we conclude the document, closing the main environment by saying end document. And that's it. I mean, fairly simple, and what it results in is a document like this. So we have a title, which typesets the LaTeX logo, and then we have our two equations, and that's pretty much it. Like, I don't know if, well, yeah, on the projector, I think it looks a bit bad. A lot of pixelation going on. But on my monitor it looks okay, and you can maybe later review the video also. Like really, really beautiful stuff. Actually, we will have to do something with this pixelation eventually. I don't know what's going on in there. But okay. So, yeah. Implementation, so this is something that I've already sent information to you about. So we have MikTeX, which is the biggest ecosystem of LaTeX packages. We have also TechLive, which comes standard in Linux. We have MacTeX, which I've also tried and used, but on a recent Mac I actually installed MikTeX. I think it's a bit easier to use, and with recent Apple Silicon, Lix also works very fast. It's just amazing stuff. You click on generate or compile, takes like a couple of seconds, and that's it. Really, really cool. So, and this is with MikTeX, so I would suggest, I mean, it doesn't really matter. I mean, all of these applications are compiled into a binary at some point, like this PDF LaTeX or what have you, and they're just distributed differently, but MikTeX, I think, is a safe choice for most people. Right, so, and what we are going to be looking at today is Lix and JabRef, the two open source applications that allow you to approach writing as what you see is what you mean instead of what you see is what you get. Well, Lix specifically, JabRef is just a bibliography managing application or bibliography editor. Yeah, so these are the things that we are going to consider. So here's an example taken from Lix. It's a screenshot from Lix from a few years ago. This one, I think, is still Lix 1.x something, 1.6. I don't exactly recall. They have done tremendous work since then in improving the user experience, the design, various dialog boxes, stuff like that. But the main idea remains the same. You have the document where if you're using lots of mathematics, which is primarily the reason I'm using LaTeX, to be honest, from the beginning. So it will actually show you everything. Like, this is a pretty complicated equation, you can probably agree, right? And so typing in as code would be really, really, I wonder if you can even see this equation. I don't know what's going on here. But in any case, so it's pretty complicated, just trust me with this one. So it took a while to kind of get it right. First time when I was a master's student still, I needed to write a bunch of complicated equations. It was really fun, to be honest. But okay, point is that it's visualized here. Imagine if it were in code, it would be much more difficult to digest it. So that's one of the things. And when you compile it, here you are. So again, let's see how that looks. Well, I guess you can see it, but it's somehow pixelated still. So it looks quite good, and that's what we care about. Part of this fun factor working with systems like LaTeX is enjoying the output. Like, when you're starting out, you write some text and it comes out as beautiful, right? Just out of the box. You don't have to do anything except writing and inserting maybe some equations, some technical stuff. But in the end, it does this hyphenation for you, make sure that the text is easy to read, that it is well adjusted to the column width and so on. So it's just a pleasure to work with, and eventually you get this nice feeling when you see the final output of your work. So that's a major contribution to this fun factor, that you actually experience pleasure writing and seeing how beautiful mathematics are, or whatever text it is, how beautiful it comes out on the other end once you compile a document. And I mean, we should never underestimate this fun factor, right? As researchers, as scientists, we do the work, which is not always fun. So lots of experiments, maybe lots of, thinking about abstract concepts, figuring out some relations, and so on. Okay, it's also fun once it works, but it might be challenging. So then you actually want to put it to writing in such a way that it is also beautiful. So you want to convey this beauty that you have discovered into this written word, typeset it in the best possible way. And so LaTeX actually gives you this ability. Okay, Text Studio, this is an example of, I wonder how that looks like. An example of some code written in Text Studio, which has also been improved tremendously throughout the years. But this is for those of you who prefer to work overleaf style, like with pure LaTeX. But it does also generate the same kind of beautiful output, so it doesn't really matter which one you use, because you still get the output, right? So, I mean, Lix uses LaTeX under the hood. Doesn't really matter if you prefer to work. I mean, there are people like control freaks. They want to control every single, backslash in the document. I'm not one of those, thankfully. So I work with Lix, and it's easy, it's fun, it's productive. So I don't need to work with code unless I'm on overleaf. It's also okay on overleaf, but with Lix it's much more productive. Right, and we're almost at the end of the lecture, of the slides, by the way, so just a few more. And we get into the fun stuff. So, and one final, well, there's actually some bonus stuff as well, but the important thing now is this BibTeX manager, which is JabRef, again, open source software, and they have also improved it tremendously in the last years. So this one is similar. Probably you're aware of Zotero, Mendeley, and applications like this. So it's just an alternative, but it is open source. And I use everything. Yeah. So I use Mendeley, Zotero, and this one as well. All of those things, because both Mendeley and Zotero, they can export BibTeX. So you can export into this one, and you can just use it there. I have like these bibliographies from my doctoral student days. They're like many files containing many references. They're in JabRef format, well, BibTeX format, and I use JabRef in order to manage those. But I don't shy away from anything that makes me productive. That's the point. So Mendeley is useful, Zotero is useful, other pieces of software are also useful, but JabRef is somehow, when I start writing a paper, I just I create a new bibliography, I copy any parts of bibliographies that I may need into that specific new bibliography, and then this is my kind of pipeline. It's very fast to do with JabRef, and also if you need bibliographical entries from, let's say, Google Scholar or IEEE Explorer, somewhere there, the Science Direct, and so on, it's very easy to import into JabRef. It's basically copy-paste job, and it will process everything and put in a bibliographic entry in there for you. So, this is just an example. So probably you have figured out already that these examples work in the way that I show a piece of code, or I show a piece of like file in LaTeX format, and then I show you the resulting PDF output. So same here. So we have a bunch of entries, 6 in fact, and if you were to typeset those, again, let's see how that looks. Let me just move a little further away so I can actually see it. Pixelation. So I will try to figure this out. But the point is that it looks really nice. So you don't have to worry about anything, because you're always recompiling the document. When you need to add something to the bibliography or remove something from there, it will automatically update, and it will still typeset it very well, like professionally and so on. So yeah, some important considerations, tech LaTeX, and this is what stirs away a lot of people, especially new users, and some of those I've mentioned already, like problems with Unicode, fonts, that you get to use. But there are implementations which I also use, and in fact the example with the automatically generated document was produced with different kind of font, which is not a standard LaTeX font. And for that reason there, I think one of these alternative implementations were actually used. I don't remember which one at the moment. All of this can be overcome, is the point. It's just that a lot of people, you know, when you're leaving the comfort zone, it's always like, this doesn't work. I don't need to leave that comfort zone anymore. Whatever, I will not use it. But then they're missing out on some of these nice features. So another example, this is not an open source software, so it's not part of the main presentation, but I just wanted to throw this in there. Maybe you don't know about it, but if you're working with mathematical expressions a lot, you may find this useful, because this thing can actually convert written math into LaTeX, and then you can just insert it into LaTeX or whatever you're using, and it will just work like that. So it's called MathPix Snip. Again, it's not open source. It's some sort of AI solution. Well, you see, now we're getting to AI finally. So it's some sort of AI solution that they offer as software as a service, and they have this tool that is called MathPix Snip, which allows you to just take a screenshot from your current active window or whatever, and then it will recognize the math, and it will spit out LaTeX code corresponding to that math. So the problem is that it's paid for service. You do get 10 snips for free, and usually I think it's based on statistics that most people don't actually use more snips in a month, let's say, because it renews every month. For instance, I have not been using this a lot lately, maybe because it's faster for me nowadays to just type in the equation. It is there. 10 snips you can get. I think with an academic email, so that's any email, the domain of which ends with edu, I think you get 20, which is more than enough for most people. But let me show you just how it works if I can remember the key combination. Okay, let me get out of this mode. So it should be, and also let's remove Teams so we don't get distracted. Some other stuff as well while I'm at it. So let's see. Interesting, I don't see it here. Let's just run it then. It's called MathPix Snipping Tool. In some ways it's similar to Microsoft, this whatever it's called, Math Panel. So let's see if it, here it is. So now the shortcut should work. So you can just use, like, look at this, it's some handwritten stuff. So let's try and run this snipping tool here. And here we go. So yeah, it was able to recognize it completely, even though this is well, quite low resolution. And so you can see that also here we have, it also detected, this is amazing, it detected the font for this L, and so it used the correct thing in tech for that one. So if we just quickly go over to LaTeX, oops, not this one, let's just start LaTeX. I'll just show you how easy it is. So in LaTeX we create a new document, and we create a math equation, we paste it, done. Right? So that's pretty much it. It even recognized this log function. It's awesome. Okay? So for mathematical expressions, if you actually handwrite something and you just want to quickly convert it into tech code, this is the way to go. And the most efficient one that I know, at least. So it's very useful. Let's keep it open for future reference and stuff like that. Okay, so yeah, further reading for you guys. We have Donald Knuth, of course, the tech book. Not recommended reading, to be honest, unless you really want to delve deep into this stuff. Then we have Not So Sure Introduction to LaTeX 2 Epsilon, which you can read, but only if needed. So this is kind of home reading for, you know, people who really like to read the stuff and understand what it is. Yeah, so basically that's it for the slides. Let's now get to some hands-on stuff. But before that, I need to figure out, oh wait, now pixelization is gone. Where is it? No, still not gone. Let me try to figure this out. So we are starting with a blank canvas here, no files at all. Meanwhile, let's see, display settings. So right now I'm on this display resolution. If I switch it, I'm afraid that part of the stuff, it will be kind of vertically stretched, but let me try this one. Still, I think there's still pixelization going on. Let's see. Yeah. Okay. Some sort of scaling issue. Let's see if I can fix it as well. 100% scaling. It doesn't change much. Let's see if 150. Okay. Yeah, maybe this is a little better. Let's see Lix. Yeah, but this is still screwed. Oh, damn it. I don't really remember having such problems here previously. Okay, let's try this one. Okay, now it's stretched, but maybe it will look better in Lix, at least. Okay, so these guys can now be seen at least. Okay, good. But it is stretched, so sorry about that, but this is how we'll have to continue. Okay, so now we get finally to this hands-on portion. We have 1 hour left, which is enough. And here the idea is that we will just start creating an article. I mean, why not? We will be using Lix and also JabRef. So oops, I didn't want to do that. So I have this launcher installed on this Windows machine, which is called Listery. So Windows now has its own launcher as well, but I'm old-fashioned, I still use that one. So we can launch JabRef also. Okay, there are no scaling issues here, very good. Right, so let's get started then with some interesting stuff. So of course what we're going to do is we'll just start writing some paper. Based on some literature, definitely. So today, the second workshop that you will have is with Jeffrey, and he will be speaking about writing literature reviews in the age of AI. I have not seen his presentation, so it will also be surprising to me what he delivers. But we will be doing this right now the old-fashioned way. So just to show you how all of these tools are working. So let's go to Scholar, Google Scholar, for instance. What I did, by the way, is I also installed this JabRef button or assistant, which is here, which technically allows us to grab any stuff from the existing page and to automatically send it to JabRef, which is what I'm hoping for. Now in JabRef, of course, what we need to do is first we need to create a new library. So I will create this new library, and here I will also save it. Now, using the same approach as I have mentioned previously, I will just throw myself into the actual working folder, which contains all of this stuff. And let's call this workshop. So now it's called workshop.bib, and this is where all of our bibliographic entries are going to go into. And concerning the specific topic for the paper, I think it could be interesting to start looking for literature that actually has to do with AI and writing. So let's try that. Artificial intelligence in research. Okay, so we have artificial intelligence, a powerful paradigm for scientific research. Let's see what this is. The Innovation Open Access. I don't know this journal. Oh, how many authors are here? Seems like some stuff from physics, where they have up to 200 authors or something like that. Interesting. Okay. Artificial intelligence coupled with promising machine learning techniques, well known from computer science, is broadly affecting many aspects. Blah blah blah. So what is it about? And undertakes a comprehensive survey, developing fundamental scientists. Broad research guideline on fundamental science. Okay, reading this abstract, I don't really understand what the paper is about. Let's see some figures. Artificial intelligence. So I'm actually looking for writing assistance, just to be clear. So no, this is something that I don't want. Let's try it. Writing assistant. Application of artificial intelligence, powered digital writing assistant, in higher education, randomized control trial. Okay, this could be interesting. In the journal, how do you pronounce it? Helian? I know, so this could be interesting. But if you click on it, what you will get is this PDF. Here, let's see, full view. Okay. Okay, this seems relevant for our task. So here, let us try and press this button here. I will show you both ways to do it actually. So the first way, you can just push this button once you install the thing. So it does all the stuff, sends to JabRef, and then it shows you select the entries to be imported. So if there are multiple entries on the page, it will actually give you several results here. But currently it has detected this application of artificial. Okay, looks good. So let's import entries. And now we have an entry. Now with JabRef, one thing that I really suggest to do is to learn at least the basics of BibTeX syntax, because okay, there are required fields here, of course, but then if you look at the source, you will see that there are some things that maybe are not really necessary here. So for example, there's a file link which actually could be useful, keyword, short title, URL. It actually filled in a whole bunch of things here. But this is where it's most easy to remove any information that you don't want. So just go to source and then select, let's say, what it is that I don't want to see here. Let's say abstract. I don't want abstract for whatever reason. Boom, gone. Just make sure that the structure remains correct here. So we have the specific meta item equals, and then in these brackets and the curly braces actually. So this is what we use to group things in LaTeX, and it also works here. So all of these entries are here, because otherwise you will run into compilation issues, you will hate LaTeX, and you will hate me for giving you this workshop, so please be careful. Okay, so yeah, this is basically what we can do here. Then, of course, you can save it. Yes, and one more thing in JabRef that you should definitely immediately configure is something to do with citation keys. So citation keys is the way that you recall stuff for citing in your paper. And this is where citation keys become really important, because let's say you have author, in this case it's Nazari, is the last name of the author, and then 2021. But maybe you're also going to cite other works by the same author in the same year. So what will happen is JabRef will automatically append a suffix here, like Nazari 2021 A, B, C, D, and so on. but how much is it telling you what the actual content of that paper is when you're looking for the key to cite. In LaTeX, again, this is alleviated, but if you're going to use overleaf later, this is important to kind of make sure you understand which specific paper you are considering to cite. So in order to fix this, the first thing that you do when you install JabRef is you go to Settings. Let me just remember where those are. File, Preferences. And in here, you have a tab which is called Citation Key Generator. So the default pattern here is author year, like this. So what this results in is last name and then the year. But it's suboptimal, as we have just discussed. So what you want to do here, actually, instead, is you want to make sure that your pattern contains short title. So you can choose among different kinds of citations. You can actually customize it further, but my suggestion is to change this pattern. So there's a question mark here, which will give you all of the possible configuration options. We're looking for short title. I mean, you can configure it as you want, of course, but my generic suggestion is to use something, this guy over here, short title. So because this will give you an idea of what the paper is about, so you don't get lost in these different things. So author year, and then I type in dash, and then short title. And that's pretty much it. So I just append this little thing here, short title, and again, if you're looking where to find it, it's here, question mark. It will take you to the web page where you see all of these options, and then you just append this guy here. I'm pretty sure dashes are allowed in citation. Let's see. So now what will happen is, of course, the key doesn't update itself, but because I only have one entry to actually demonstrate this for you on, what I will do is I will regenerate this key by clicking this guy over here in this side tab or side panel. It will ask you one or more keys will be overwritten. Continue? Yes. And so what has happened? Nothing has, oops. Nothing has happened. Let's try again. Ah, okay, I know what happened. It didn't update here. So let me just do it once more. So I forgot to press enter like this and then save. And now it should work. Let's try it again. Okay. But dashes are actually unallowed, I guess, or I forgot to insert it. Let me see. Yeah, I inserted, but it's not allowed to be there, so let's just remove it. And one more time, just to be on the safe side. Okay. So now you have last name, year, and application, artificial intelligence, which doesn't tell us much. So what you can do is actually add. So digital writing assistant. Just be mindful that if you regenerate this key, this will be deleted, and again, the first 3 words of the paper will be appended instead. So don't regenerate all the keys, just make sure that you know what you're doing here. Okay, so save. Now, because we imported it this way, we now have also 2 additional opportunities. We have this file, which if you click on this guy over here, it should take you directly to the PDF of the paper in question, so you can easily, quickly review it. But you don't really need to need this paper to be online. It can actually be offline, downloaded somewhere and in storage on your drive. And then you just change the link, which I think is, let's see, file annotations. So it's somewhere here, basically. Yeah. So you can change that. For me, the easiest way usually is just to go to the source, and I can see PDF, and then you just replace URL with path to the file on your hard drive, which is easier. But in any case, you also have this link, which if you click on it, you are presented 2 choices, URL or DOI. DOI, of course, stands for Digital Object Identifier, which is the way we reference stuff, so that it doesn't get lost. So here it is. So you can still get it. Assuming you're online, right? Yeah, so that's just how you insert entries. in one way. There's also another way you can do it as well. So let's actually see. Somebody's probably has already referenced this paper. So we're going to do some forward snowballing, which is one of the techniques for literature review. Cited by 84. Nice, nice. So let's see. Systematic review of AI-based automated written feedback research. Okay. ChatGPT and academic writing self-efficacy, unveiling correlations and technological dependency among postgraduate students. Okay, let's just click on this then. All right, so Scopus, yes, the study investigates the impact of ChatGPT usage on academic writing self-efficacy, blah, blah, blah. Some statistical results, prolonged ChatGPT engagement. Okay, this looks to be an interesting paper that I would definitely want to keep in my literature review. So what I would do is, let's see, of course I can just click on this button since I do have this guy installed, but what I would prefer to do is to show you the alternative approach of, interesting, look at this. I will skip to this paper. I will not tell you the reason, but okay, artificial intelligence, okay, this is an excellent paper, I think. Not just because some of the authors come from Estonia. So let's see if I can find this. So usually it's a UX flaw if I'm looking at a record. Okay, it's Scopus, but I'm looking at this record and I immediately cannot see the DOI. Okay.
The previous page, I guess there was. If you compare.
Here we are. DOI. Look at this. Okay.
The previous one there wasn't the under of this paper.
All right. Fair enough. But again, usually DOI is something that you're immediately looking for, so it makes sense to put it in the center of attention. Anyway, I'm not judging here design, or do I? In any case, so yeah, the other way you can import easily these things is by, of course, using the digital object identifier. And what you would do in this case is what I did here is I just copied it, and what I will do is I will just paste it here, and that's it. So it imported the article, and you can see all of the meta information. Now, it didn't import as much as the previous approach, so if you want all of the stuff, including abstract and so on, you can use that one. But if you want like something that is more tangible, here you can also just use the DOI approach. The idea is that the digital object identifier is unique, pointing to the paper, so you can just maybe even drag and drop. I haven't tried this, and I already have this paper, but this is one way that you can actually do it. Now, in this case, you don't get a file yet, but we can also try to do this as well. Let's see. Oh, wait. No. Wrong option. Why do they have these options here? It's redundant. Come on, get some lessons from Apple. Scopus document download requires an okay. I think it's easier to just go to this DOI because it will not be Scopus, it will be the actual place where it's located. Wait, what happened? So, research work is hard, as you can see. You always have to do things like this, many copy-paste operations. Okay, so now we're in Science Direct, and here you see DOI is immediately visible. This is what we're looking for. Okay, so view PDF. I will just show you how we can save this PDF so that we can recall it from our local computer. So it opened for me in browser, but using Listery, I can quickly throw myself here, and usually what I tend to do, this is my kind of pipeline of work, but feel free to adopt if you feel that it helps you somehow. So what I do is I create these research packs where I have a single literature bibliography file, and I also have PDFs that are associated with it, and everything is in a single place and you can easily access it offline. I like this concept. Unfortunately, I didn't have time to work on it as much as I wanted, but this is how I do it. So now we have a structure where we have this workshop guy and we have the PDF inside of this one, and what I will do is I will simply copy the file name, which is, come on, it's 2024. Can you please create a naming scheme that makes sense? Elsevier, come on. I'm telling you, research work is hard, but maybe you know already, so. Anyway, so I will just show you how to link this file here, if I can remember where it is. I think it might be general. So here, let's click on plus and just search for this guy. Okay, basically that's it. I really hope that it's a relative link, but you can always go to the source. Yeah, it is. Okay. Very good, so they fixed it. It used to be a problem. Now if I save this bibliography and I click on this file here, it should just open. Yep, offline, nicely, everything works. So, so the idea of this research pack approach is that you collect files like this. So you have your bibliography, you have the PDF files, and then at some point what you do is you just zip them up. In this case, add to archive, something like this. And here's your research pack, basically. You can share that with the people who should also have access to this literature, right? So, or have access provided through them, to them through the institution. But yeah, you can then share it with your colleagues, and then they can have a look as well. And then you can also actually create the LaTeX file, which we are about to do. So we have 2 references right now here, and that's enough to get started. So let's go to LaTeX now and get started with some of this stuff here as well. So I will also run magnifier. Sometimes it might be relevant. Right now it is not, so I'll just kind of collapse it, but yeah, let's work like this. So with LaTeX, you also get a whole bunch of templates that you can already use for different kinds of papers. So if you go to File and then choose New from Template, here you are, a whole bunch of things. Now, in technical science, very often, if we are, let's say, writing a journal paper or conference paper, it might be in IEEE transaction format. Again, IEEE, right? So again, it comes back to us, which is very nice. So in any case, there's this IEEE Tran conference, journal, and so on. And also some others. Elsevier should also be here somewhere. Yeah, here it is, El's article. So let's actually go with El's article. I have nothing against IEEE, as you know, but let's just have a look at this alternative example. So you open it, and immediately, let me just discard the previous file, and immediately there's a whole bunch of things jumping at you, right? So, however, let's go through them bit by bit, so you will be accustomed to these things. So just scrolling through it, it's not a lot of content here, which is actually good for us because we want to get started with this stuff. And also instructions in the form of these notes. So here it says, this is a template for a LaTeX file for articles to be submitted to journals of the Elsevier Publishing Company. Blah, blah, blah. Journal is specified in the document preamble. For the right document class options to get page format for your journal, have a look at the El's article documentation. So right off the bat, where is this preamble that we have previously also discussed? So you go to Document, and then Settings. Fairly easy. Document, Settings. Here's your document, here's the settings for this specific document. And in here, you can see that we have document class. Let me just zoom in a little bit, make sure that okay. So, and here it says Elsevier. Now, there are no predefined options here, but with El's article, you do get options, and you can actually put them here to specify the configuration of the article, as you would, let's say, with Overleaf. It's the same idea, basically, but here it's hidden behind this front-end UI. And the preamble itself, if you scroll down in the list of all the configuration things that you can make on the document, you will see here at the end LaTeX preamble. Click on it, and here is where you specify the journal. So journal, example, nuclear physics B. Fine, let it be like that. Although the topic that we're actually discussing is AI writing tools, but let the journal be this one. Whatever, it doesn't matter. So you can click on. Actually, I don't know what this edit button does. It's a new version of LaTeX. I may not know everything here. Can I change this? Yes. Okay. Let's enable line numbers, for example. Let's do this one. Apply. Close. Right. So let's zoom out. And in LaTeX, the way you generate documents is you click on the eyes over here for preview purposes. So you click on the eyes. You wait a couple of seconds. Actually, it will take longer the first time you do it. And here you are. So, nicely typeset document according to Elsevier's journal article guidelines. So you have the title, the authors, some stuff here, abstract, keywords, introduction, and all the other stuff. So where are my line numbers? I don't see them right now. Okay. Okay, let's try again. Document settings. Okay, this is here. Okay, maybe it comes with a different class option. I don't know. But for now, let's just remove this from here. Doesn't matter that much. Okay, so the easiest way is, of course, just to... This might be lunch. So you agreed that it would be second floor, or? Okay. So what is written on the whiteboard is not accurate anymore. But okay. Once we get to lunch, we will know. Right. So yeah, we start with a template. It's always easier to start with a template, right? It's of course possible to also start with a blank document. In fact, it's so easy. You just press Control N. And then you can just start writing, but I don't know. Maybe let's keep on going with this template. So title note mark. Okay, so it's a bit complicated scheme here. What happens, but there are title footnotes as well. So you don't need them usually, but sometimes this could be used for thanks, as in acknowledgements. So if you have specific acknowledgements for, you need to cite funding sources or then things like this, then this is where you can also do it. Like, let's say here, let's actually edit this one, and let's say this document is supported, or this research is supported by IEEE Estonia section Young Professionals Affinity Group. Why not? And then the second one we don't have, so we will just remove it here, and we remove the label since it's no longer necessary. And here is a text that explains the author styles, so either author side by side or like this, but the style that is here is actually okay. So let's just remove this, so to make it a little easier to see what's going on. It's still not easy, I can probably I can tell, but since you're editing it, it should be maybe, because there's a lot of stuff going on here. There are authors, there are author footnotes, and corresponding author texts and all that stuff, but it's just according to the journal guidelines, right? So, and at the end of the day, it's still easier to use than just code it in Overleaf or something like this. And by the way, if you're interested how the code looks, you can also have a look here by going into View and then choosing Code Preview pane. And then if you click on these guys, you can actually see what is here, either current paragraph or complete source. Just don't leave this open for complete source like this, because it will slow down the editing of the document. You don't want to do that. But the complete source is here, and you can see that this is the actual markup, but it translates in LaTeX for this specific template as something like that. All right, so in order to make this a little more easy, let's actually remove a whole bunch of stuff here. So we do have address label, which I think it makes sense to keep. And you can tell that it's the correct label because these match over here. So we have author label and we have address label. So let's remove the second author. Oops. Yep. Corresponding author text as well. And the second author as well. Actually, I don't need a footnote, so let's remove this. And if we've done that, then we also have to clear out the second author. And now what we're left with, okay, so this is an example of author style. We don't really need this note right now, so let's just remove it. And then there's abstract here and some keywords and stuff like that. Again, we don't need them. So keywords AI, writing assistant. And here, let's just replace this with so you see, it's a bit delayed, this typing, because I have the complete source open. So let's close this for the moment. And here I can also write my own name. So what I did, oops, mangled it. So what I did here, actually, I inserted something that is called a non-breaking space. You do this by pressing Control and Space in LaTeX, and this will make sure that the initial stays glued to the last name here. So we don't have we have corresponding one, but do we? Okay, these guys are options, and let's just remove them. Or was this it? Okay. All right, so we removed a bunch of stuff. Let's see how it looks now, if I can compile it. If I see errors, then it will also be good. Okay, the second title footnote, which is longer. Okay. Second footnote. Let's remove it. Like this. All right. Right, so basically we've made some modifications, and now we can see that these actually reflect in the document. And the way that these different things, probably you have this question that how do you insert all of these different parts here? So usually they are in this little guy here, which is top left corner. So if we zoom in, this is where you set a bunch of these different sections and environments and so on. So you would go here, and then you would choose for the front matter, because this is front matter after all, you would choose the specific kind of thing you want to insert, like title, title footnote, author footnote, corresponding author, address, email, abstract, keywords. All of those guys are actually here for this specific layout, because there could be different layouts, and in LaTeX the idea is that the layout file is the way that you abstract away from needing to write code, right? So you have a layout, and so all of those things, if they are supported by the layout, will be in this little box here that you can just take, and then you can use that directly. So, oops. By the way, zooming in and out works here in LaTeX itself. So if you want, you can like make the font a little larger and stuff like that. So usually these notes are distracting. So let me just remove them as well, and that we end up with the specific layout here. So it doesn't occupy as much space. Right, so the title of this document would be AI Writing Assistance for Research and Development. So now we have the title, and by the way, also let's save the document. I will save it here as AI Writing. Yep, okay. So let's just generate it one more time. All right, here we are. So this is the basis for a document. And already there's a bibliography as well. And I'm not sure that bookmarks are inserted, but let's see. No, there are no bookmarks, but this can be configured also with links. So, right, so now we should start writing some content. And here is where I will actually show you some typical ways you would be working with LaTeX, inserting images, bibliography entries, tables, and so on, because all of this is highly simplified with LaTeX compared to this is the thing. Use here the command. So the notes are actually useful, right? Use here the command line numbers and enable the package line no in the preamble if you need the numbers. So I wasn't paying attention as much. So the way we do it is we will insert something that is called evil red text, which is enabled by on Windows Control L, and then you just type the command that you want, line numbers in this case. And then we have to re-enable this line stuff in the preamble. So once again, document settings, and we enable this guy here, press OK, and now we should have line numbers. Let's see. Yep. Okay, very good. Yeah, so if you do need line numbers, in that case you can easily enable them as well. I think it's mostly useful for review purposes, like when you're submitting your paper for review. Right now they make things a little bit tedious, so I will comment out this line numbers because this is the comment in LaTeX. So it will still be here, but it will not be as obnoxious with inserting those, which I don't really need. So, okay, here's an example of appendix, and here also, as the appendix, they inserted the bibliography. There's a BibTeX generated bibliography, and then there's also some references in plain bibliography, which both of them are acceptable. I'm not sure that you need to insert the bibliography in this specific way, meaning that I would appreciate it if it was not appendix. I'm not really sure why they inserted here. Let's try to remove it. So I'll just not even Control X. Oops. Now let's comment this out, and then let's just remove it. So I will show you the complete procedure of inserting this bibliography. So in LaTeX, what you do for productivity's sake, you learn a bunch of shortcuts, keyboard shortcuts, like Alt-I stands for insert, and from here you can also choose the specific thing you want to insert, like float, which is A, and then you choose whatever you want. But in this case, what we are interested in is bibliography. So you insert bibliography, and then this guy pops up, and then you just insert the specific bibliography, like from the local database. You just add it, and you also choose the style of the bibliography, which, by the way, I don't know which one, or I don't remember which one Elsevier uses, so let me go back, because there's already this generated bibliography. L's article, Harvard. Okay, so I can go forward as well, edit, redo, so a couple of Control Y's, but it didn't reinsert the bibliography. Fine, I'll do this again, list, bibliography, and this would be L's article. So I think also searching for it should work. L's article, yep. Okay, so if you start typing in the style guy here, L's article, HARV, Okay, this is the style, and then you need to add the actual bibliography from a local database. So you would go and just click on this workshop, edit, and click OK. And that's it. You have inserted bibliography. Now let's see if we can immediately use it. For this, I will actually remove all of this stuff here. So introduction in, and then in order to insert a bibliography, there's a shortcut key which is Alt-I-C, which stands for citations, and now you can immediately see all of your citations in the document. So there's the Altma citation and Nazari citation, and you can sort them, you can do, you can search them, and so forth. So all of this is supported here. So let's double click on this, which pulls it into the selected citations list. There's also the citation style, and by the way, I can already see that something is corrupted here, which I don't mean to steer you away from this, but it looks like there is a problem, but it's good. Let's see what happens if I actually try to compile it. The authors question the usefulness of AI in assisting research endeavors. So right now I can see that there's a problem, but let's see. I can just compile, and probably I will see an error, or I don't see an error, and the bibliography comes up wrong. Yep, that's the thing that happens. So in the law, the authors question the usefulness of AI in assisting research endeavors, and then there's this guy here. And remember, this is exactly the example that I've shown you previously, that in LaTeX and with plain BibTeX, you need to write something like this in order to get typeset properly. And we're currently using Unicode, and this is something that you need to consider when you create the database. I think with this general template, this is what you will have to do. It might be the case, because here I think it's Unicode. So if we go here, there's the database library properties over here. And library encoding is UTF-8, which is Unicode. So this is correct, but unfortunately it doesn't really work well here at the moment. So let's see if we can do something on the level of the document. For that, you would go back into document settings, and you would go into bibliography, or whatever it's called here. Let's see. Here we are, bibliography. So default style, blah, blah, blah. And then processor here, if you take a closer look, is BibTeX. BibTeX is 8-bit processor, which will not understand Unicode and will typeset stuff as you have seen previously. So let's actually try to change this. I don't see BibLaTeX here. Well, let's try BibTeX 8 and see if that changes anything. I don't think so, but let's see. So, okay, it just tries to open the same document because there were no changes here at the moment. All right, so yeah, this is something of an issue, because depending on the general style, they may not be fully updated to the latest BibLaTeX advancements yet. So in that case, what you would have to do is you would have to check every entry when you actually create it. You would go to library properties, and here choose, here library mode is BibTeX. What happens if we change this to BibLaTeX and save it? So let's save this document, and in fact, let me close this document and open it again. No, still a problem. Let's see if it compiles. Yeah, still the same problem. So I'm actually very glad that I found this example, because it shows you that not everything is smooth, but don't get hung up on this either, because it's a very simple fix. You just need to remember to do it as well. So I will save this one, then I will go to library properties again, choose BibTeX, and here I will also find something like Windows 12 51 and apply, save, and now we should also reload the document one more time. Alright, so now you see it has been fixed. Of course, you need to know what to do, but eventually you learn, and now everything's okay. So, now we just have 20 minutes left, and I want to also reserve some time for questions. So, let me, as a final thing, show you how we can insert figures, tables, math into this stuff. So, first of all, let's create a new section. Again, it makes sense to learn the shortcuts for productivity's sake, but you can also go here into this box over here and choose section from here. So this would be second section. If you want to do this with the keyboard, the shortcut for that on Windows at least, I assume on Mac it would be similar, something like Alt-P and then space, and it will just open you this drop down, and then you can do the same thing, second section. All right. Now we just type text. That's it. You don't need to worry about markup or anything like this. What you can do is you can also insert a label, which is useful if you want to reference the section later. So Alt-I-L will give you this one. And in here, by default, LaTeX does a lot of housekeeping for you in the sense that here there's a label which says section colon, second section. You create this one, and then the label will be automatically created here. So whenever you need to do something like we discuss this issue in section dot unbreaking space, and now Alt-I-R, and now here you see we already have this label, so very easy to reference, and they will always, when you compile the document, they will always be recent, so you will never run into an issue of wrong numbers of sections, pages, whatever, what have you. So here I just double click on this, and now I can see section, this guy, dot, save, compile. I mean, one of the things with LaTeX is its flexibility in creating these always working references and citations and so on. So, the answer question is we discussed this issue in section 2. So right now the link to section 2 doesn't work because we have disabled hyperref package. By the way, in order for it to work, you can go to Document Settings, and then go to PDF Properties, and here you can tick this box which says Use Hyperref Support. Tick the box, click OK, and now when we generate the document, it should actually oops, I put a dash here. Well, whatever. Interesting. Hyperref may not be compatible with the current setup. Okay, scratch that. But you can make it as a link in other classes as well. Okay, so second section, I want to give a few examples. An example of inserting math. So for math, you have two options. You have inline math, which is a shortcut for that would be Control-M, and then you can just start typing some stuff like sum of, I don't know, x squared, something like that, and this will be rendered as inline math. Or displayed equations. For that, you use Control-Shift-M, and you get like displayed equations, meaning that it will be like centered here, and you can do pretty much the same, like let's say sum from, I don't know, n1 to 10, and again n squared, something like this, over n. And you can also insert a number by typing in Alt-M-N, and then you can also insert a label as usual, and this will be equation, let's call it equation 1. Simple, fast, productive. Let's reference equation and Alt-I and R, and then equation 1. So I use it as plain reference, but you also have other options, like you can use equation reference like this, so then you don't really need to specify these parentheses. And let's compile that. And here you are. So the equation reference works correctly, the equation is numbered, we have this guy here, all of this stuff. But you can also, of course, when you're going into equation editing mode, you also have this palette that becomes available at the bottom here. So this is where you can actually select Greek symbols, specific styles, like whatever you want, like some symbols, like usual ones are sums and integrals and parentheses, and all this stuff is available here, also matrices, by the way. Right, so this is quite easy in terms of math. And now let's speak about floating structures. Those are the guys that you use to insert figure floats and table floats, and that would be Alt-I and then A, and then you have here figure, table, stuff like that. So let's insert a figure, some figure, which would be the caption, again Alt-I-L, and this would be some figure would be the label. Usually you want to center the figures. This is where we use evil red code, centering. You don't have to. You can also go here and you can choose paragraph style, I think, but I prefer to do it like this. It's just, it will tell you immediately, okay, we have a centered figure. Now I don't have a figure yet, so let's go to here. Maybe we have some sort of figure as well. No, not here. And maybe here something. Let's see. So some figure from here. So let's just do it like this. Well, actually, we don't need to do it like this, right? We can just save image as. Don't do it. I mean, it's a copyrighted image, but just for the sake of example. Then you want to insert a figure, so Alt-I, and then it would be... Honestly, I don't remember the shortcut for this, but you can do this from the palette as well. Your figure is here, so let's now choose the figure that we want to insert, which is here. Now, very importantly, here, a lot of people desire to set figure size in absolute units. It's much better to actually use relative units in LaTeX. So when you want to set, don't scale graphics like ever. Just forget about this option. Choose this one, set width, and then from here, instead of centimeters, scroll down to the to some reasonable stuff and choose column width. Why? Because when you will be copying this stuff into another paper, for example, it will still be valid that you will still see the figure occupy either the whole text width or column width, depending on if it's a multi-column document. So here, let's say I want 90%. Click OK, and here we have a figure. So what you can do, though, is in LaTeX options, you can scale on screen, like you don't want to see this occupy the vertical space as it does here, so let's make it 20. Well, maybe too small, but at least 50. Okay, so now we have 50 here, and you can still see what it is, but you don't have to, the screen space is not wasted on it, let's say. So let's generate this document, see what we get. Yeah, so the figure went to the next page, but everything is okay. So we can see figure, some figure, stuff like that, and you don't have to worry about its positioning or anything like that. Okay, and one more thing that, yeah, okay, let's also reference the figure. So, and also the figure, and Alt-I-R, And here, the good thing is that, don't forget to change your reference type, you can also sort them and you can also group them. So if you have different kinds of things that you want to reference, for example, equations, figures, sections, and so on. So here, for example, I want to reference a figure, so I tick this group guy, and then immediately if I have many of those, right, it's difficult to sort. So figure, I have some figure, I click on this, and here we are. So now we have a reference to the figure as well. Let's generate the document. And here it is, figure 1. Always recent, always correct number. Right, and another thing, these floating structures, if you right-click, there's settings for them, and here you can actually choose where they should be placed. Usually default placement works well, but for example, you can choose for them to appear on page of floats or something like that, or bottom, top of page, stuff like that, which you configure usually in code, but this is here as well. So let's say top, bottom of page, here if possible, something like that, and it will then take that into account. So, and finally, let's insert another float, which will be a table float, some table. And you know how, if you've worked with LaTeX before, you know how tedious it is usually to construct tables there, because the markup is horrible. Horrible. I repeat myself. But in case of LaTeX, this is one of the things that I actually use it for a lot. Like if I need to create a table for typesetting and overleaf or something like that, then I will actually go to LaTeX, I will create the table there, and then I will copy it. Because it takes so little time compared to just typing it. I mean, you can do it, sure, but it's suboptimal at best. So captions go above the tables, as we know. Now we only need to insert the table. So here you can do it like this, done. Usually what we want to do is we go into the settings for the table, and then you have here formal table, a bunch of settings here as well, like for example width, again use relative width, something like column width, and make it the table 90% of that. And well, maybe that's a little bit too much, looks like. Okay, something horrible happened to the table. Let me delete it. Not easy anymore. So this sometimes also happens, but the good news is that we can just remove the float, start over. Again, also insert the label. Insert the table, so something like this. This time I will actually start with the width. Let's start with something more reasonable. Let's try this one. That still doesn't work well. Ah, this is column setting. I'm sorry. Yeah, this is because it's column settings. I guess I can undo that. So table wide settings, width, column width 90%, which doesn't show, and formal. Oops, whatever. Try this again. So the good news actually is that you can copy from Excel, let's say, to here, and it will actually copy into the table, so it's pretty fast to create if you have some numeric data, for example. But let me try to just compile this now, see if it works, because we're running out of time as well. Okay, so decided to put the table on top of the paper here, which is something that I don't want to happen. So we can go to settings, and instead we can say page of floats or bottom of page, something like that, so that it appears somehow in a correct place. Okay. Still, this is suboptimal, but usually you don't have tables on the first page of the paper. So, yeah. But you can see that this table with some work can actually become something useful. And there's also, like when you're working with the table, when you click on it, there's this palette over here, which allows you to add rows, remove rows, and do like various things, like center stuff, left align stuff, align on decimal if you have numeric data, and so forth. All of this does take some getting used to, but eventually when you make it, you can be really productive with this as well. And with that, I think just one more comment concerning this overleaf situation, because it is important for a lot of you, like if you're, by the way, who is using overleaf? Can you show of hands? Okay. About half of people. So yeah, overleaf in this sense, I mean, the way I would approach this problem, I mean, you don't have to, but the way I would approach this problem is I would, if you want, you can still use overleaf, of course, but if you are the primary author, let's say, of a given paper, what you can do is you can really productively and fast write it in LaTeX, and then you can do export, because this is something that I've not even shown previously. So file, export. Here you can of course export the PDF, which is the final output of your paper, but then there's also LaTeX. So you can export it to LaTeX, PDF LaTeX, and then just transfer that over to overleaf, along with all the figures, bibliographies, and all that stuff. And you're done. And then you can invite the authors who will contribute to your paper. So this is one workflow that I envision could be really useful, because personally I am using this specific workflow. If I am the primary contributor to the paper, I will create a LaTeX file. I will type in quickly like the research, literature review, all that stuff. And if I have multiple authors, there are actually two ways you can approach this, because here in LaTeX there's also integration of I cannot see it here right now. I don't remember where it is, I guess. But there's integration of version, here we go. Integration of version control, which means that you can attach Git to this guy, and then you can just use Git in order to work on the documents in multiple author setting. And then there's also change tracking, which actually works quite well in LaTeX as well. So you can just enable track changes, and anything that you start typing, like some new content, will be highlighted, and now of course you can accept change, reject change, do the usual stuff as well. So this works really well. Let's say if you submit your document to your supervisor, and then some track change with change tracking enabled, then this can be worked on in this way as well. So there's another workflow that is possible with LaTeX with respect to that. But with that, I end almost at 12, so I don't want to keep you too much from the food, but any questions, please? So like multi-page tables. Yeah, thank you for this question. I've had a lot of pain in doing this, also with LaTeX, but it's possible to do. So here in the table settings, you can go to table settings, and you have this tab here which says multi-page table, and you can enable it here. Right now I cannot, because there are some settings that I have already changed in the main table, but in general, yes, you can use it here. I think the table cannot appear inside a float, because it's not a float anymore, it's a multi-page table. So you just, when you insert a table into the text, then you can make it so. Let's just quickly see if I'm correct. So right before bibliography, we will insert another table just like this. Again, it's change tracked, so it shows up as well. And table settings. Now I can do it. So I can tick this box, and then it will appear like this, and then you can choose the different options in there. And yes, you can make a table like this. Let me just give you one quick example of that. Triple access. So one of the papers that we have fairly recently published that makes use of that is this one. And this was actually authored in LaTeX. It's a fairly comprehensive paper, so it does take a few seconds to load. And we're almost there. Here we are. So table 1. So this one actually spans 3 pages. I don't have the source file to show you right now, but it was done in LaTeX and later converted to Overleaf, but initially it was done in LaTeX. Any other questions? Yes? Can you speak up a little bit? I can barely hear you. You don't. It's just one of the workflows. So the idea there, yes, the idea of that workflow, if you have a multi-author environment and the other authors are not familiar with LaTeX, then usually what will happen is you will first write yourself as the main contributing author and then transfer to Overleaf so that all other authors can contribute. I'm telling you about this workflow because I have experienced this many times. I have colleagues who do not appreciate LaTeX for whatever reason. They don't want to learn, they don't want to leave comfort zone, whatever. They just work in Overleaf. So as the main contributing author, I type in the paper completely. The first draft I do, and then I transfer it to Overleaf so that they can contribute. That's the only reason. Yeah. Yes. Yes. It can do everything. Okay. Any other questions? Hussein? So yes, it's using the approach that I showed. It didn't work for this template for some reason. You go to document settings and then PDF properties. There's hyperref support, which is a package. Here it resulted in some conflict, and I don't honestly remember conflicts stemming from else article style, so I cannot immediately fix it. And yeah, this is a bit of a problem, but this is how you do it. And if we were working with a plain document, it would immediately just work out of the box. And then you would get the bookmarks, the hyperlinks, all of those things will be working then. Create diagrams? Work diagrams. Okay, you have multiple options for this. You can just use something like, there are a couple of packages that support this. Actually, there are more. Off the top of my head, TIX is one of the packages. Okay. I'm not exactly sure what you mean by work diagrams, but something like this? Okay. So honestly speaking, I prefer to use external software for this. There's Inkscape, which was mentioned in the email that I sent. Another opportunity is Draw.io, which is an excellent, they have this open source desktop application, which is called Draw.io. You can actually create, it's not LaTeX, but you can create SVG from here. SVG or EPS or some format that is vector-based, and it's still good. In Inkscape, there's actually a method to export a diagram into LaTeX code. So Inkscape again, Inkscape, here we are. So let me just give you a brief example of that as well. So we have, let's say, a couple of boxes. Doesn't matter what they are here, and some connecting stuff, like maybe something like this. Maybe too small. F1, and a little fatter. So something like that. And now what I can do is I can go File, Export, or maybe not, maybe File, Save As. And let's see. Here we are. So LaTeX with PS tricks macros. So you can choose this one. Let me also go to this one. And here we are. You see? So basically it allows you to export it. It might not be optimal, so let's see if we can actually do it, because with PS tricks you need the engine, you need the generating engine to be specifically, I mean, let's replace this diagram here. Change tracking is enabled, so let me just accept this if I can. Come on. Okay, let me disable change tracking. Some things require a little bit more elaboration. So let me paste this code right here. It will fail, I can tell you, because PS tricks does not work with well, actually it didn't fail, okay. Or it did fail, it didn't do anything here. But in this case, I think what you might want to do is you might want to change the PDF viewer or generator mode to PS to PDF. And then it should work, hopefully. Takes a few moments. Well, no, it still doesn't work, but it's possible to make it work. It's just one example that you can consider. Usually, I will not bother with this. I will simply create the diagram in Draw.io and then export it into vector shape format and use this as an image file. So, but that's my preference. You can use TIX, you can use PS tricks, but PS tricks is, has these quirks. TIX is better in that sense. There are also some additional packages. Off the top of my head, I cannot remember which ones, but you can probably find them. Okay, any further questions? Yes, please.
I have a comment about overlay.
Yes.
That you want to use overlay because you want the premium features. Then if you are Katrin member, then it's possible to get premium for free. For that, you have to simply go to this TalTech website, and then there is like some setting that you have to basically toggle, and then after that you have more premium features, and you just have to pay for it.
Recently, IEEE stopped using overlay features.
I don't know, I got to have premium feature and through that the TalTech feature.
I was actually a student member. I was using only premium features. Recently, IEEE stopped and that only does. So after allowing the members to use premium features.
So it seems that code has discovered.
Yeah, so there's it's actually an interesting discussion because I still have access to premium features on Overleaf, although I'm not a paying member, so I don't have premium. But when I log into Overleaf, it says you get premium as a member of this Collaboratech. So for me, somehow it didn't stop. But a lot of my colleagues actually told me that it stopped for them. So now I'm responsible for creating all the projects. Because if you're an owner of the project and you're a premium member, then you get to use the premium features, and everyone else also get to use the premium features. So that's something to consider. Okay, anything else? Yes?
One question, I used Overleaf once. I mean, I felt like formatting certain journal members with Word is like tedious. Then Overleaf for text is much easier. Then I stumbled on certain problems with tables. Like in Microsoft Word, you can it's like you can freely modify the table, like mark in columns or rows as you want. But that's issue with text. Like, I think you cannot mark it column wise. It doesn't allow even with some certain package I tried. And then when you this is one issue. And the second issue I found when you submit a journal article to initial submission, you have to like put the figures and tables after the writing or review the fields. So what happens, like, I think LaTeX optimizes the tables and figures its own way. So sometimes figures are not in like order, sometimes table comes in between them. So how can we like solve this?
Yeah, it's actually a good question and a very relevant one for users that come from the Microsoft Office ecosystem. It's possible to solve, but I cannot tell you this like in 5 minutes time. So it takes a little longer to elaborate specific styles and things like that. Everything is possible, but it's true that with LaTeX it takes a little longer to format tables. Figures, it's not an issue, but with tables, yes, it could be counterintuitive in some sense. Then you will spend some time in figuring out how to format this table. It remains an issue, so it's a very relevant comment. But it's still with LIX, you can do this much more easily than with LaTeX. You don't have to, think about this markup, where the line goes, what the margins are, what the spacing is. You can always configure this with LIX and immediately see. Generate it and see what it looks like. So yeah, that's a very relevant comment. Thank you. Okay, so let us continue our program. Today we have here a very special guest, professor from TalTech, Jeffrey Tuhtan, who will be speaking about doing literature reviews in the age of AI. So without further ado, the floor is yours.
Thank you so much, Aleksei. First of all, it's an honor and a pleasure to be invited to this event, which I have not been to before. So some of you I recognize, some of you are new, fresh faces. Just to give you a little bit of background why I think Aleksei invited me to be here with you today. So I've been teaching the academic writing course for the IT faculty for 8 years now, and then for the last 2 years the course has been expanded, and now I teach academic writing for all of the TalTech faculties. So I'm guessing, but I think that's why he invited me, because I've read a couple hundred papers in the last 8 years and have a pretty healthy idea about what a literature review is all about and how AI affects the scientific writing landscape. But I would like to talk to you about two other things first. So the first thing I'm going to talk about today is actually the history of the scientific journal, because I think that is a lost bit of knowledge. So we are very focused today on our research activities, and we are very focused today on doing our individual research. At least I hope so. I hope so. I hope we're busy doing our work. But how did we get here? So when I teach the course, I ask the students at the beginning of the semester to do a diagnostic quiz, where they give some background, and then one of the questions is like, what is a PhD all about? Like, what is the purpose of the PhD? I know it sounds very kind of existential and philosophical, because it is. What a PhD is, what it is to do research, is actually very personal, and it's very different for every individual. It's not something that you can actually define in a simple sentence. So I asked that question to the candidates in the course, because I'm interested to find out, for all these different reasons, why people are doing PhDs. It's just a pleasurable, interesting thing that I would like to know myself as an educator, as a researcher. And I can tell you roughly half the time the answer is to write journal papers, or to write papers, or to publish stuff even. I'm in this course because I have to publish stuff to get a PhD, and that makes me sad a little bit, because that's really, the paper part of things is just like a byproduct, and so it shouldn't be that way. And so I hope that in our brief time together today, I have 40 minutes. According to my clock, I have 42 minutes left, 45 minutes, 42 minutes left. I hope I can convince you to think otherwise. So my job today, in this brief time we have together, is to convince you that a scientific paper is actually something really, really important. And to convince you that when you have your name on a scientific paper, that you're very proud of it, and that you're part of a community, and that it matters. And I want you to feel good about being part of this community. So I hope that at the end of the day you leave this room with a sense of deep pride. And for those that have published conference or journal papers, that you feel a renewed sense of hope and confidence as a professional researcher, which is what you are. Okay, but it's going to take a little bit of work for you to feel prideful. So let's just start at the beginning. Science is a uniquely human endeavor. Can we agree on that? Can we agree that if there weren't humans on the planet, like dolphins and elephants and donkeys and birds are not going to be responsible for science? Can we just agree on that point? We could have a whole discussion. If he ever invites me back, we can do a whole thing on like animal intelligence, and it's fascinating. But let's just begin this discussion today, this lecture today, with the assumption that science is a uniquely human endeavor. It's a cognitive outcome, so it involves our thinking and our brains and things like that, but it's a human thing. Okay, everybody agrees. If you disagree, let me know. Okay, good. So science is a uniquely human endeavor. Okay, but what does that mean? What are the implications of that? It means that if we go away, science goes away too. Right? If we go extinct, science goes extinct. Oh, well, that's not good, right? Okay, let's go back a notch. So if science is a uniquely human endeavor, then we have to keep it alive, much like a fire is kept alive, right? You can think of it as a sort of fire. It has to be kept alive by the community. You're going to hear that word a lot today, so I apologize in advance if that word gets like burned into your brain, but it's very intentional. So the community, that means that there must be a subset of people, the scientists, let's call them, right, who are responsible for keeping this thing alive. And I really mean that. So if humans are gone, science dies. Not every human is interested, capable, willing to do science. Can we agree on that also, right? There's a lot of other things you can do. You don't have to do science. You don't have to be a scientist. So what is it to be a scientist? For many years I resisted calling myself a scientist because I don't have a degree in what's called the natural sciences. But I now call myself a scientist. And I think anyone, even without a degree, can call themselves a scientist if they choose. Because to be a scientist really means that you apply the scientific method. And what is a scientific method? What is it, really? It's
reproducible.
That's right, it's reproducible. Reproducible. I was going to make a bad joke, but I stopped myself here. So yes, it's reproducible, but it's empirical, because everything on the planet, everything that has to do with humans is experiential, and therefore the reproducibleness of science is really about reproducing experiences. Whoa, think about that for a second, what that actually implies. It means that science is a unique endeavor that occurs in the mind of human beings. It must be maintained and kindled by a community of people who are willing to practice it, right? And it only exists as long as we follow the rule that it has to be reproducible. If people start doing things, publishing papers, putting out data sets that are not reproducible, is that science? No, it's not science. It's just stuff. Okay? It's just stuff. It's not reproducible. It's experiential stuff. A book of poetry is not science, because You cannot use that to make reproducible stuff, okay? That is the fundamental differentiation when we create things, the creative act. If you create something which is scientific, it means that if someone else takes that thing, that method that you applied, takes the concept that you came up with, they can experientially reproduce it to a certain degree, right? We can agree on that. So there's going to be some uncertainty and so on in there, but they can reproduce it. Okay. If somebody reproduces your poetry book, you're going to sue them because that's a copyright violation. It's not the same. It's not science. Okay. So we didn't have science. We didn't have any kind of way to share our science until we started writing stuff down, which is actually, so now we're starting off with humans are responsible for science, and it's an experiential thing that follows one simple rule, which is it has to be reproducible. How do you get that knowledge out of your brain? Right? My grandmother, may she rest in peace, was an amazing, she could make amazing pies. And those recipes died with her because she was a very, very stubborn woman and she didn't want to share her pie recipes. Right? What happened? I know the flavor of her pie. I know the scent of her pie. Right? I know all those things. Those are experiential things. But I can't reproduce the pie because Grandma didn't leave me the frickin' recipe. True story. True story. But we watched her as she got old. She didn't kick you out of the kitchen with the wooden spoon quite as fast in her 80s. And so we made notes of Grandma making pies. And we kind of were able to recreate most of the things that she did. She used a lot of nutmeg, by the way. If you make an apple pie and you put some nutmeg in there, that's gold. So I'll give you that one for free for apple pie. So you can, by watching others, imitate the act of what they're doing. Imagine you are an early human, hominid, and you are in the cave, and the guy over there, he's the best spear thrower, he gets the biggest animals, and he's chipping off stuff, and you're watching him, how he chips it, and you chip it the same way. So the act of imitation of watching someone and reproducing what they're doing, you can learn, you can do science. Science can be expressed that way. You can watch the scientist with the pipette and you can mimic those motions, right? We agree? So that's the easiest and simplest way to keep science alive, isn't it? Watch the scientist, repeat, okay? But that's not very practical, is it, right? Isn't very practical. And in fact, hundreds of years ago, that is actually, if you went to Oxford, you ever heard of Oxford, this place? Oxford, Cambridge, these universities? There is a word that we use in academia, perhaps you've heard it, it's called a chair. You've heard that word, a chair? Someone is a chair of this research institute. I am the chair of this. It's a very important position. Do you know where that word comes from, chair? If someone is chairing at Oxford or chairing at Cambridge, nowadays it means they have a very high-level position at those universities. If you go to a German university where I attended, for example, there's a thing called a Lehrstuhl. A Lehrstuhl means literally a learning chair. A learning chair. And there's the head of the Lehrstuhl. The person is the head, like the top professor in that domain is the head of the Lehrstuhl. That's very weird, because as far as I know, German academics and UK academics were not really, they didn't have like an EU-wide system like 500-600 years ago. So where did this idea come from? I'll tell you, it came from the fact that scientific communication up until 400 years ago, roughly, was actually done that way, where we mimicked things. And the word Lehrstuhl, the word chair at Oxford, literally meant that you paid for a chair, a frickin' chair, and you sat there, and you sat in your chair, and the professor would come and they would sit in their chair, and you would pay per lesson, right? You would literally pay per lesson to sit in the chair. And if a person was really, really good, the university would even give them a permanent chair. And they would come in every Tuesday and talk about medicine or mathematics or science, and they would sit in the chair. That was their chair. And they only got that word, the chair, if they were good enough to earn it. And that's literally how we did science for hundreds of years. Literally. Okay. There's a guy that came along, doesn't matter your religious affiliation, but he was really angry. He was a German guy. He was really angry that people couldn't read the Bible. So he translated it into German, started giving it out. Do you know his name? Martin Luther. Martin Luther, this guy here. So Martin Luther, he had a plan. I'm going to share some knowledge with the human community, this Bible thing. It seems pretty popular, you know, pretty popular. In the Western world, the Bible's a pretty popular book, whether you like it or not. Something happened when Martin Luther did that. So he started sharing the information, but instead of people going to church, instead of people coming to college and sitting in the chair and hearing the priest, right? I'm not saying that religion and science are in any way connected. I'm just saying something very interesting happened. Another guy took some blocks of wood and cut them and carved them into the shape of letters and numbers and started printing books. Uh-oh. Now we're in trouble, because now the chair can start writing things down, can start sharing the information with other people, can't they? And now you have the birth of the scientific journal. The word journal comes from the French word jour, or day. And people started writing down what they were doing that day. I am going to my physics lab, and I'm going to roll a wooden ball down this chute, and I'm going to write down, journal, I'm going to write down what I did that day in my book, my notebook. And then if it really, really works well, I'm going to go to one of these printing press people, and they're going to print up my notes on astrophysical observations, on gravitational, balls falling down on the ground, on, there's a lot of stuff in chemistry. Of course, chemistry was a big deal, because everybody wanted to make gold out of stuff that was cheap, like horse manure. There's like a lot of really bad books. But they were all about the scientific method, because people were like, if you drop this wooden ball 50 times like I did, you're going to get this effect. And here's the way to do it. Right? If you mix these two things together, it's going to go kaboom. And here's the way to do it. If you want to make your sword metal sharper, stronger, to kill the enemy, here's the way to do it. And for the first time in human civilization, we had the ability to communicate science, the empirical, experiential ability to repeat things with people that were hundreds, thousands of kilometers away. Okay, so that is a noble tradition. That is the root source of the journal. So I hope that when you see a journal, when you utter the word journal, it has a different meaning and a feeling for you now, because it is a journal. It is a day. It's the day of your experiential sharing with others. It's the way that the community is able to create science, to kindle it, to keep it alive and well. I'm going to check the time here. Very good. I had 15 minutes for that part, and I'm at 14 minutes and 55 seconds. I am good. Okay, now we're going to move on to phase 2 of this lecture. How did we get where we are today? How many of you love the current paradigm of publishing papers? How many of you don't love it? I would use a word, but I know I'm being recorded, so I'm not going to use it with how I feel about it. It's a very naughty word. I think it's beep. That's what I think. Okay? It's not. Something happened. I just told you in 15 minutes a love story about science and human innovation and the frickin' printing press and the jour. I use the French word. I don't speak French. That's like the only other word I know besides merci. That's a lovely story. What happened in between? Okay. Let's talk about what happened in between. 1665, magical date. That's when journals started coming out. That's when the Royal Society started publishing. That's when the Germans and French started publishing. Because books were relatively cheap, there were postal systems, so people could actually share letters with each other and communicate. Science communication was born. Okay. What happened in between? Let's go. So 1665. That's where it started, up until nowadays, which is just a hot mess, okay? So let's go backwards from now to that point, to 1665. Okay, so I'm 45 years old. I've been publishing papers for around 20 years now. I'm just going to take you back 20 years. at the beginning, because I can do that very easily, right? 20 years ago, when I was doing my PhD, when you wanted to get a paper, I had to go to the library in Stuttgart, Germany. That's where I did my PhD. I had to go to the library, and I had to talk to a human being. You know those things? You know, these lumpy things with shirts that are these are humans. I don't know what that thing is. You freak me out, that little weird robot thing there. I don't know how I feel about that. Anyways, I had to talk to a person. I had to tell them what I wanted. I'd like River Research and Applications, 1986, Thompson and Carruthers, method for mean streamflow estimation and turbulence monitoring in an alpine river. Okay. Lady would write it down on a piece of paper, and about a month later, I'd get a knock on my door, and there would be a lady with the cart. She would roll through. Tutton, Jeffrey, yes, here you go. Whoop. And I would get literally an envelope, and inside the envelope was the journal article. And I was like, yeah, I got my article. This is amazing. I've been waiting for this. Thompson and Carruthers, 1987. This is a great paper. And it was like, even back then, you did not dare to use a highlighter or a pencil, right? Because that was like, it came from somewhere. I don't even know where. It was shiny and glossy and was like high quality printing and stuff like that. So that was 20 years ago. 20 years ago, the vast majority of scientific communication journal articles were not on the internet. They were just not. You could find them using online resources, but you could not physically get them. The PDF files were not available. That's only 20 years ago. Okay? Another thing 20 years ago that was very different than today, you oftentimes wrote reviews, printed them out, and mailed them to the journal. I remember doing reviews, like literally on my computer writing the letter and literally putting it in an envelope and mailing it to Wiley, mailing it to Springer, and my professor, one of my professors and mentor, Helmut Kobus, at the university there, he invited me down one day. He had retired and was cleaning out his office, and he invited me and a few of the other PhD candidates down. And he said, well, guys, you know, I've finished with the part of my career where I'm writing papers. So I have my collection of papers. And you can go through them, and you can take whatever you want. And we were like, wow, this is amazing. And he had cartons and cartons and cartons, very well organized, of papers. And we got those papers from him and brought them back to our offices. And that is how you got papers. That's how the peer review process worked. There was a huge amount of time and care put into writing those. There was a huge amount of time and care put into collecting those papers because they were not at your fingertips. Knowledge, you would go to conferences and you would talk to people to find out about papers to read. That was a big, important topic of conversation. Somebody would take you over here and, hey, come here, kid. Yeah? I see your work. I like your work. You're doing good work. I'm going to tell you about some papers you should read because you couldn't find them. The knowledge of where the methods were, where the repeatable science was, that was actually in the heads of the community itself. There was no one to just blindly get that information from. People were the gatekeepers of that information. The professors, the postdocs, they actually had a vast, meticulous internal Google Scholar. And they would know not only what to read, but they would tell you what to read based on the stage of your career, on what they thought was your technical ability. We're going to get to these things in a minute with AI. They were able to, from your presentation and knowing what university you were at and looking at your general level, you know, are you a first-year student or a fourth-year student, are you a postdoc, are you an assistant professor, and so on, they were able to recommend literature tailored for you. Special for you. That means you didn't have to go through the process of just finding a bunch of stuff and kind of scanning it and screening it. Someone that was more knowledgeable in the field, in that topic, was going to share and tell you what the tailored, I'm going to use this word again, the tailored scientific reference should be for you at your stage, for you to be using that information properly. Almost like a magic recipe. They would say, you should read these 3 papers. What about this? No. You read these. These are for you. Ah, interesting. Interesting. So that was 20 years ago. So I went back to Kobus's office to get some more papers. And he was down there in this box of what I thought at the time were kind of like leftover like scientific data sets. It was like a box with a lot of tape and like yellowed pieces of paper, and they had like drawings and scribbles and stuff on them. And he was looking for something and kind of muttering to himself in German, and I thought, oh, maybe I don't want to interrupt him, so I knocked on the door, and he turned around and oh, Jeff, come here. I don't have my glasses. I'm looking for this diagram, he said. And I thought, oh yeah, he's completely lost his mind. He's looking for a box of like paper scraps and tape, and he's asking for a diagram. Like, this guy is, But he wasn't, because 20 years prior to those 20 years, so now we're going to go back 40 years when Kobus was a young ninja professor, diagrams and figures and tables were actually little pieces of paper. And there used to be people at the university that were artists that would draw them. You would give them the data, and they would draw the graph. If you wanted a logarithmic axis, that was like a special thing, because that's a lot of work. You really need this logarithmic, Nowadays, we just go in Excel or whatever we use, or Python or MATLAB, whatever, and you just click on the button or you change the command and the axes change. But back then, a person had to actually physically draw those little tick marks on there, okay? And I will admit, in some of my papers, I've actually done it too. Yeah, sometimes you have to make it with, draw them in manually. But anyways, so 40 years ago, we not only had everything in paper form, but everything was what I would call analog. Analog, like you and me, we're analog, right? So all of the diagrams, all of the graphs, everything was done by hand. Everything was custom. Here, I'm going to throw this word out again. I'm foreshadowing a lot, because the next part, the final part of the talk today is going to be about this very specific topic. Everything was very customized. Everything was tailored. Everything was tailored to that exact paper. Every figure, every table. There was no copy-paste back then, right? Everything was done with a certain amount of detail and care and attention, which was just that one thing, okay? Now, see how we're doing time-wise. Okay, I got 3 more minutes for this section. There's one other aspect. So if you wanted to get scientific literature 40 years ago, you had to go through humans. The humans would talk to you. They would help you filter it. If you wanted to publish a paper, you'd have to do everything by hand. You'd have to draw it out. Everything was very, 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 very analog. So the only other thing that separates that analog making of papers, let's say in 1960, all the way to 1660, there's only one actual difference between the papers in 1660 and the papers in 1960. And that is the concept of the journal peer review. You see? Because when people first started writing journals, they were literally journaling and reproducing the work that they did. Galileo had journals. Isaac Newton had journals. It was kind of like your recipe book for doing science in that field, and then you would just publish them with your name on it, and then they would go out. And then people could buy them or not buy them. Galileo, I don't like guy's a knucklehead. I don't like his stuff. I'm a Newton person, Or I don't like the way that I don't like the way Newton has his formulations. I'm more of a Leibniz kind of a mathematician, Whatever. The Euler family, like, good Lord, how many books did they produce? So many. So the problem with this is that sometimes people made mistakes. Oh. If you made a mistake in your journal, right, as a sole author of the work, usually they were sole author works, if you made a mistake, there was nobody to tap you on the shoulder and say, listen, you got the graphs flipped, man. It should be up, not down. There was nobody to help you with that. And so by the time it got to the printing press, and the printing press people were very nice, they were very helpful, and they got those books out and they shipped them all over the world, and people could read your amazing scientific work. The problem is the printing press guy was not a physicist or a chemist or a mathematician, couldn't really find those errors, and sometimes even the printing press person might make a mistake, right? So could be C instead of G. And now suddenly we're not talking about the speed of light, but we're talking about the gravitational constant. Oopsie doodle. And if you go back to really, really old works, you find those mistakes all over the place. So you can go download some old, really old, like scientific journals from like 100 years ago, 150 years ago, and you'll find that the printer is like, ugh, I don't want to use this letter anymore. And so like halfway through the paper, they'll start using other nomenclature, which is very difficult for the reader to follow, but it was just the way things were done. And this started scientific flame wars, because someone would write a letter and say like, hey, Newton, man, page 34, you got some stuff wrong. And then it would cause this giant reverberation back and forth, letters going back, letters going forth. We know this because we have a lot of these letters. These people were just constantly battling. So then the idea came, listen, we at the Royal Society, we are going to have a committee and we're going to take a peek at your stuff before you can put the stamp of approval on it. Oh, how does that work? Well, it's going to be peer review. Peer review. Someone's going to take a look at it, a peer. So a peer is a person which is appointed back in the days. A peer is a person that is appointed. If you go to the British system and you see the peers, these are people, special people. These are not just random people off the street. These are peers, and they're appointed. And the peers would then review your work. That's where the word peer review comes from. So the peers would review your work and make comments, and then you would ignore them or you would integrate them. But what happened was you had peer review. Now you had this intermediate step between physical publication of your analog work, and you had you coming up with your original ideas and material and disseminating it to the wider community. So that is the only real difference fundamentally between 1665 and 1965 is the concept of the journal having to go through peer review. And then from 1965 to 1985 to 1995, now we have the slow digitalization. So now I'm typing things on my computer and generating papers. I can search for papers online. And now you have from 1995 into the present, I would argue full digitalization of academic communication, of scientific writing. And what does that mean? It means that everything is available. All the papers that are produced nowadays in the last years are all digital in some way or another. I would argue there's almost no journal publication today, a modern publication, which is not digital. Maybe it exists, could be. The Journal of Printing Press and Postal Workers, maybe they only do things physically and mail it to each other back and forth. I don't know. But I would argue that everything, we've gone full digital. So we are no longer analog. We are full digital. Okay? That's the world that we're in. Okay, now we're gonna finish today's talk with the last part of this. So, in the first part, I wanted to give you a deeper sense of why we have scientific papers, where that comes from. I think we got there. Second, I wanted to give you the changes, the most important changes in academic writing from 1665 into the present, and those are fundamentally the creation of the printing press, the ability to create analog works and mail them to each other. That's the first one. The second one is the invention of peer review, so that if we make a mistake or if the community goes, I don't think this is correct, that you get feedback before you make that analog copy. The next one is the digitalization of the analog product. Okay? Okay, so those are the three things that have happened between 1665 and now. And now I will argue in the last part of my talk today, there is a fourth change. A fourth change. The fourth change is the application of AI to the body of literature that exists, that's digitalized. okay? And that is why I am here. That is why I was invited here to talk about this. So it took me 30 minutes to get to the point. Sorry about that. I am a little long-winded. But the point I want to make in the last 15 minutes is this. The fourth revolution, I believe, will be the customization of the scientific paper. It will be the tailoring of the scientific paper. It will be a vast improvement in the quality and the rigor of peer review, where the review is not only done by humans, but also to some extent done by a process called artificial intelligence, which can generate responses from text inputs mostly, but increasingly also from imagery and sound. And so now we have the ability to revolutionize the literature review. So the literature review has a very simple purpose. It is to aggregate and communicate across the discipline the current state of the art. Let me say that again. The literature review has a very special place in academic communication. It is to aggregate, to collect, right? And to disseminate, to share, to explain, to summarize the current state of the art in that field. That is the sole purpose of the literature review. If you have, how many of you have done literature reviews? Yeah. They are my least favorite type of paper to do, personally. I like reading them, I do not enjoy doing them. It's just a lot of thankless work. That's why whenever I get a literature review, I'm like, oh, thank you, I don't have to do this. It's very difficult work. I think it requires the most mature researcher at the most in tune and depth stage of their career to do a good literature review. To be honest, I think it's really it should be the gold standard of the academic paper is literature review. So now we have information that's online, that's digital. We don't need to do the effort in finding these things. I Googled literature review tools on my phone just before coming up here. There are so many tools with so many names, I don't even want to go over the list. I can't even tell you how many different companies, some free, some not free, and so on, are offering scientific literature review software, online tools, and so on. So I'm not even going to talk about specific ones because I think it's irrelevant. And those of us that work in the tech space know that in 5 years it's going to be completely different stuff anyways. So go for it. Use it. Right? Good. What's going to happen with the use of AI? So the AI, it will understand you, just like the old professor, because it can go through your literature. It can know what stage of a career you are at. It can know what particular technical competencies you have. It can judge that probably better than most people because it can take a vast body of knowledge, your publications, and it can aggregate that with its vast body of knowledge on the fields. So AI is the ultimate interdisciplinary. When I say AI here, I'm referring to these large language models, things like ChatGPT and so on, just to be specific in this context. So the AI systems are way better multidisciplinary scientists in a sense, right? Because if you put in the input prompt, right, it should give you a repeatable reply outward. So I would say that engaging with an AI is, to a certain extent, part of the scientific act. Okay? Now you can add things like make it more natural and add jokes and silly things in there, but I think if you really stripped it down to an input-output relationship with these large language models, they should be consistent enough that they can be considered a scientific instrument. Okay? So now we have a new scientific instrument that is able to understand context. It's able to understand what you're good at versus what you're good at. So if you put in the prompt for your literature review and you put in exactly the same thing as this gentleman here, you're actually going to get tailored, customized, differentiated responses out. Because the AI will know, yeah, but you're leaning a little bit more this way, you're leaning a little bit more this way, therefore your review should be over here and your review should be over here. And I think that's amazing. We haven't had anything like that before. Never. We had to go to these people who kind of knew us well enough to recommend things, and then we could do a literature review based on that. Now we have everything is digital, and now we can give the information to the AI that it understands the context of the reviewer, and through that lens then projects the literature review to the community. So I think that is what's going to happen the next, I don't want to put numbers on AI because it's a crazy thing how fast or slow. I don't want this to be on YouTube years from now. You said 5 years. It was like next week it was already out. So I'm not going to give you numbers. So, but I think there's going to be an after that phase. The after that phase is that the AI literature review is going to be multilingual, right? Because it can read French and Swahili and just as well as it can read, Japanese and German. It's going to be multilingual. It's going to include things which are not in the scientific realm. So things like patents, government agency reports, regulatory frameworks, things like this. And so the breadth and scope and depth of these reviews will be so vast and so profound that I do not believe we will be able to interpret them. What? Let me say that again. The literature review as it is now is to collect information. Okay, AI can collect the information. It's to aggregate the information, to put it together in some meaningful way. AI can do that. To disseminate the information, this is where I believe the radical shift will occur. Right now, it's being disseminated still. Like, imagine we had an AI which wrote the entire literature review for you, right? So it takes your profile and it creates the literature review that it estimates you would have written, right? It's not an unthinkable thing. And so that's a product of the AI. It just generated that thing. And then it generates the same prompt for you and you and you and you. And then it begins to map the researcher, right, as the lens through which the literature review is projected, and it actually begins to map those individual reviews through the lens of the data profile of the researcher, right? How are we going to read that? How could we possibly read that? How could we possibly understand that? It's a multi-dimensional data matrix interacting with itself. It's not something that we are going to be able to comprehend. Oh no. How are we going to make use of that review? How are we going to make use of that review? And as that process unfolds, as the review itself is reprojected through the imagined experience of the individual person who's now, in the context of the AI, a very intricate, delicate, complicated web of data. As that gets reprojected through that system, I believe that that system itself will understand science in a deeper way than we currently do. You see? Because science is experiential, isn't it? Right? Science is experiential. Science is about shared information. Science is about shared knowledge. Science is about taking that knowledge and putting it into a format, an analog paper, then the digital paper, then I would argue a very complex sort of data matrix, right? But then for the first time, through the act of the AI literature review, for the first time, we will have something which is doing science, and it is no longer human. I believe that's the fundamental outcome of the AI literature review will actually be an AI which can do science without us, which understands science more deeply than us, that embodies what we think it is to be scientists. It will be the first time on our planet that science no longer becomes only a human endeavor. Thank you.
Thank you very much. Okay, so any questions?
couple of AI is like the creativity side. It's fully acknowledges the creativity to what's existing. And it doesn't have the capability to come up with totally new things for the system. Because I have for example, I have written papers on topic that didn't exist before I started writing them. So when I did my first paper, I didn't have anything to cite because nobody else had written on that topic. And I came up with this topic after reading 500 papers and then noticing that there is actually a topic that isn't covered.
That's a very good question. I think I can answer it, unfortunately, because I would be much happier as a person if I couldn't answer that question. Let's first begin by considering, I think, the more fundamental and integral part of your question, which is what is it to be creative? What is it to be creative? What is the creative act? There's a fantastic book, actually, called The Creative Act. I recommend reading it. So, what is it to be creative? To be creative is to be novel. To be novel is to do something which has not yet been done before. Okay? Can we agree on that? The creative act is a physical instantiation of novelty in the world. So it's a physical instantiation. That's a big word, but that is a very important and carefully chosen word. It's a physical instantiation of something new. So the only way that something can be creative is it has to do something which at time t is equal to 0 did not currently exist, and that thing has to literally pop into existence, physical, real existence, at time t equals 1. Can we agree on that? Okay. I can do that in a trivial way with a random or pseudo-random number generator. I can take anything which exists now and I can pop on a 0.136 onto the end of it if it's a numerical value. I can add a word, cat, to the end of it if it's a sentence. And if I do that enough times, I will be able to randomly generate anything that I want. And so if I have something which exists now, plus a clever way of combining randomness with that thing, I can be creative. And I think that if you use tools like DALL-E, if you use very, very sophisticated large language models that have randomness as a key feature, that you will see that they are very creative things. In fact, I would say that because of the combinatorial speed at which these random processes can be integrated, I think that they are close to, if not more creative already in things like performance art, like singing and music generation. So if you check these fields in art, so if you're an artist and you want to draw a picture which is creative, that I think that these systems are already on par with or better than humans in terms of creation. So what realms of creation are left to us, I think, is the question that you were asking, really. What realms of creation are left to the human endeavor? Currently, that would probably be things that are emotional, because to the best of my knowledge, these systems are not there. We don't really know what emotions are quite yet. And the second thing is things that are related, that are keenly related to the physical, experiential part of being a human, going to a wedding and crying at your cousin's wedding. So the AI probably doesn't know what that is. It doesn't have that emotional feeling. It doesn't have the context or relationship with your cousin. I hope not. Ask your cousin. See what she's up to. But I think that these things are still the fundamental, personal, experiential will always be something. Will always. The AI cannot take that from you because it is not you. So there will always be the creative act. And if you read Rick Ross's book, he's one of the most famous music producers ever, and he talks about that in his book a little bit, because people come in and they're freaking out, you know, they're going like, oh my gosh, I'm a performance artist. You know, Taylor Swift shows up and she goes, I'm going to be broke in 5 years because they're going to make a fake Taylor Swift AI, and he goes, don't worry about it, because the AI is not you. It cannot replace you. It can replace things that you do, you see. It can replace the act of the interjection of the t0 to the t+1. That thing, the instantiation, that it can reproduce, but it cannot reproduce you. You are a physical instantiation. You are a creative act. You are always being and becoming. Okay? I know that sounds a little bit philosophical and abstract, but you are the creative act. And the AI cannot replace you. So I hope that that answers the question. It's a very good question.
Well, I mean, besides that, we also have a panel, which starts in, 10 minutes.
I have a question about the simple question. How important the open access journals without peer review?
Well, let's get the mic here so everybody can hear.
How important the open access journals without peer review?
So the question from the gentleman was about open access journals without peer review. Okay, let's go back to our previous discussion about what the modern concept of a scientific journal is, right? So we have that list in front of us. We can go through it mechanically and answer your question. So the first thing is it a written communication? Does it physically exist? Does it have words and letters and figures? Is it a reproducible piece of text that people can read? Yes. Okay, first box ticked. So we go back to 1665 again. You tick the first box, right? What's the second box? Is there peer review? Right?
Yes.
So if there is peer review, then we go to the next one. If there's no peer review, right?
But recently, archive become very huge popular. Most of the recent scientific journals, top journals like the Transformers and all these recent advances of the generative AI models from the topmost institutes like the Google and all these papers have been published on this archive in open access journals, but without peer review.
Yes, but that I think that answers the question. It is not the current standard of the scientific community to not have peer review. It has not passed that key and very important step. So if other members of the community have not had the opportunity to read, review, and comment, then it should not be considered as valid as those works which have undergone that process. Just like if I tell you a verbal communication and I don't write anything down and I don't show you and I don't share with you my empirical method, if I just tell you some results that you believe to be true, that's not science. The reproducible act of the scientific communication must have those key ingredients. Otherwise, it cannot be classified as a scientific communication. It is a communication in a nascent form. It is a communication in a nascent form, but it hasn't undergone the necessary and key transformative steps, one of which is instantiating that into a document with text and figures that is reproducible. The second is it must undergo peer review. If it does not have those two key and transformative steps, it does not get to be classified as a scientific communication. It's a communication underway. It is something else. It's very important that you understand that as a researcher, as a scientist, that these things are very important. People may disagree on these points, and that is fine. Disagreement is welcome and important in science, but it is not part of the modern interpretation of the scientific communication. It must undergo peer review. Some of you are still awake, I see. That's good.
If we're going to be utilizing artificial intelligence to mimic us as a researcher in order to make it potentially at one point be the scientific furnace, right? How are we going to make sure that it doesn't have like legacy problems that everything is currently has? What currently exists?
Okay, that's a two-part question. So the first part was, how do we make sure that this furnace, I love that term, I'm going to take that from you. What's your name?
Aleksei.
Aleksei, I'm going to give you credit for that. So this furnace, this AI furnace, right? So how do we make sure that this thing is not generating just some kind of t is equal to 0 to t plus 1 based on all the stuff that was at t is equal to 0, right? It has these legacy problems. Okay. So there is in mathematical physics a very famous process called the random walk. The random walk. Have you heard of the random walk? No? It's a very cool thing. It's a very simple equation. You have some numerical value. Let's say you have a two-dimensional space, and you have the coordinates x and y. And you, on the next step, time step, you add a random number plus x and y. And you get 1 unit over and 1 unit up, plus some kind of random perturbation. Okay? Now, every system that's algorithmic, right, including the universe as we understand it currently, is kind of a time-stepping system, okay? So we have to agree on this, that there's no wormholes. I can't like throw a pocket wormhole in there and screw up your whole question. So we agree that the universe has sort of a time-stepping nature to it, okay? And we have a random walk. And now I take all of these processes and I start them at the axis point 0, 0, right? What happens after 1,000 iterations with this algorithm? What do you think? Where do you end up? Yeah, I don't know either. That's why it's called the random walk. Good question. So the thing is that if you start at the 0 point in 2 dimensions and you run that enough times, you can get back to 0, 0 again. Okay, and that's a fairly simple system. So if I take, there is a memory effect. That's what I'm getting to. So there is the effect of the initial condition is kind of somewhere baked into that process, even though it's random. But here's the surprising and fascinating thing. If I do a random walk in 3 or more dimensions, I can never get home again randomly. And so I think that answers your question. If the system has algorithmic complexity such that the time stepping has more than dimensionality of 3, then just the point where you started, after some successive iterations, will mathematically never have an effect from the original initial condition. And so if these models are big enough, if they are iterative enough, if they incorporate enough randomness, if we run this model for 100 years on some fancy GPU unit, then it's not only possible, but it's highly probable that that system will have erased any of the initial effects of the training data, memory, and so on, because of the random walk.
It's my real pleasure to moderate a panel discussion on a very, very interesting topic, and important topic. We have a lot of questions regarding this topic of high-end application, in fact, everywhere, and in fact, we definitely have more questions than answers at the moment. So that is why it's important to discuss and what we researchers are doing, all of us being doctors of philosophy. Let's start, and my great pleasure to have here 3 panelists. So let me introduce once again Jeffrey Andrew Tuhtan. He works as a tenured associate professor at the Center for Environmental Sensing and Intelligence in the Department of Computer Systems. And his research interests include data-driven modeling and bio-inspired underwater sensing in extreme environments. He is widely popular among PhD students. I believe
so I give easy grades, that's why.
First of all, for his courses, academic writing workshop, and the course is focused on peer-reviewed scientific articles. Thank you. Birgit Lawrence is working as a senior scientist in IT College, TalTech. She is Vice Dean for Undergraduate Education at School of IT and the head of the IT Didactic Center. She also serves as the chair of TalTech Ethics Committee.
Former chair.
Formal chair.
Yes.
Okay.
Yes. I get away.
I have information update. And she is an experienced trainer in cybersecurity-related awareness and lead many awareness projects involving close interaction with peers and young cybernetic talents. Thank you. Our third
panelists is Dr. Aleksei Tepljakov. He is working as a senior researcher at the Center for Intelligent Systems at the Department of Computer Systems. His main research interests are focused on the study of cyber physical systems for educational and industrial applications. He has extensive publishing background, has worked and continues working on research and development of AI systems. Further, he is running a course entitled Research Seminar, dedicated to teaching research skills, and he is doing it for already 5 years. So me, myself, moderator of this panel, Edward Tepljakov, professor at the Center for Intelligent Systems, Department of Computer Systems, and to say I am also the chair of the AI committee in the Estonian Center for Certification Attestation. So kind of the topic is also close to my background. And I'm really interested also to listen and maybe participate also in the discussion and to know for your questions. We first of all prepared some questions for you, and after that I will also give a chance to the audience to ask and throw some questions for discussion. And let's start from the first question I have here. So, what are some key ways that artificial intelligence tools have changed scientific research in the past decade? And who wants to start? Maybe Aleksei, you can start.
Well, sure. It's again, it's a question that requires a lot of deliberation and discussion. So first, like these, again, it really depends on what kind of AI tools we're talking about, because and even before that, this general position that I hold regarding AI systems is I treat them as advanced automation. So I don't really try to project any real intelligence into AI. I think that at most how we can treat them right now is advanced automation, which means that if we are speaking about how these different AI tools have changed the research landscape in the last decade, then we have to turn also to what actual tools automation offers us. And a lot of times also in the industry, people, when they claim, okay, we have like these advanced AI systems, it's mostly advanced automation, but it can be claimed that it's AI because it does something automatically, it analyzes data, it produces some results and so forth. So it all starts with that. Like, for example, the thing that I've shown during the workshop, one of the ways that we can actually generate a document based on this input from different people in order to create a kind of book-like document, it's also automation. Should we treat this as AI? Well, of course, it doesn't make any decisions. That's one thing. So it's not advanced automation, but it's automation nonetheless. And at the end of the day, if we use AI, let's say, for generating literature review, yes, it can do it, but it will involve several items. Not only this large language model, the only thing that it can do is actually predict the next word in a sequence, or the next token, to be more precise, in a sequence. I mean, yeah, but then it will also involve understanding the problem as well, like what exactly needs to happen in that context. And also with like the other example of recognizing mathematical expressions that I've shown, this is also an example of an AI tool which can do stuff like that. So it all boils down to the fact that whatever we're doing today, those tools that we have, they somehow make us more productive, but then we rely more and more on them. So there's this balance that is currently happening, that, okay, we have now large language models that really help us to perform research and answer questions and do all this stuff, but we also become reliant on them, and whether that's good or bad is like something that we we will have to see, but yeah, so the changes are like iterative, and indeed future science will definitely, as also Jeff pointed out, will probably look quite different from what we are used to up to this point. Would you like to follow up?
Yes. So 1.5 years ago, when I stumbled on AI, I didn't think AI was for me, because everybody was discussing before that it will come like 100 years and these kind of things. But then in the education sector, when this generative AI came available, that was a kind of explosion. So, but sadly, not everybody is using still. From Estonia, all of the teachers, I think 2.5% is using. Others are still not aware. But thinking of what is happening with the students in university, in our IT department, students are using 35-40%. They are using to do homeworks. So that has changed. That now, when they want to do their final work or theses, they also want to use them here. So this has raised a problem. So that has happened. That not everybody thinks that, okay, I can do it smarter, I can do it quicker, and I don't want to. They are not thinking that they are scientists. They're thinking that this is something I have to do, and I want to get rid of this thesis. So they are not taking science seriously. So that has helped to understand that what is science, but also to degrade the science value. In ethics in the group, we have had a lot of questions, what is okay, what is not. Different universities are discussing what are the rules and regulations to do science, but also to do the theses. And Tartu University has taken approach that everything what you do with AI, you have to put in the additional materials on your thesis. This means, I think in 90s was the same thing, that when internet came, then we had the law that when you use something from internet, you had to print it out and put it part of your thesis in the end. So that is kind of stupid, I think. In our university, we have taken approach that if you use it as a tool, then it should be mentioned in the methodology part as a tool. And if you are really generating something and using that in your work, and this is valuable, this information, that then of course you should reference it. But otherwise, it doesn't matter, because you can also talk with your grandmother. And of course, when you're talking to your grandmother and using that as a source, that everybody understands what kind of scientist you are later on. But I know that no AI scientist is referencing that they have used generative AIs. They are really looking into real sources and taking the science to the pedestal that we are doing that, even if we are using to do the conclusion or something. But with the ethics department, the community, we have now people are asking that when we are writing proposals, can we use it there? Or if we don't use it, is it a bad thing? Or if we use it, is it something that who is inspecting my work? They will tell that it's made by AI, and they will take my proposal and throw it away because it was not yours. So these kind of interesting discussions we have had.
Regarding applications writing, I know that the Estonian Research Agency officially allows using artificial intelligence. It's written, but you have to add a special chapter explaining how did you use it. And the next is on the reviewer's hand, and the reviewers will decide what to do with that.
Okay. Because that has raised a lot of questions, because nobody understands what it means. Because in ethics committee, we are thinking that if you use AI, you mean as a tool, not to the writing, but really as we are doing it as a scientist when we develop new tools. And to use and reference it as, basically I say I use Google. Should we mention that as well, that we use Google? It's the same thing. Or we use Word, because Word has Copilot inside, and maybe I used it. So this is the thing that we explain, but what we will explain. This is, maybe you have any answers of that. But
maybe for making literature review, it's quite useful. Jeff, what's your opinion?
Well, great. I'm the third one, and I got the two good answers already. Okay, so I think to go back to the original question, which I believe was, how has AI affected science?
Yeah.
I think it's chaos. That's my simple answer. So, building on what the other two panel members have said, and I agree with both of you completely, why do I say chaos? Because going back to science as the sharing, the community sharing of a repetitive experiential program, which is what science really is. It's a recipe for repeating things. That's all it is. So it is inherently a cultural algorithm, okay? I didn't talk about that weird stuff too much, but that's basically what science is. It's, let's say, a cultural algorithm that can be, it uses the language of mathematics, it can be expressed in other abstract forms so that it's as you can share it and automate it to the maximal extent, okay? So let's just take that as the base of what science is really about. It's a cultural algorithm. Now, all the tools that we use to do science before AI came on to stage were actual tools, like tools, like screwdrivers and scalpels and beakers and flasks and mirrors and lasers. They were actual physical instantiations that could not change the fundamental nature of the tool whilst the user was engaging in science using the tool. This has completely changed. Now we have this tool, right? And this tool, I put in a text prompt and it tells me where to get the literature. Same tool. I put in a different text prompt and it tells me the molecular formula for a chemical compound. Okay? Now we have chaos. Why do we have chaos? Because the degrees of freedom of the scientist engaging with their tools has just increased. I would argue almost to an infinite degree. Anything that you can come up with in a prompt, you can now engage with during the scientific act, and it has massively decreased the reproducibility of the process of science itself. And so I think that the major negative aspect that we are looking at in using AI is the flexibility and the chaos that comes out of the cultural algorithm of science, engaging with it via this tool, which has infinite, I would argue, infinite complexity in the form of the prompt.
But you love it?
No,
you don't love the chaos?
I'm very ambiguous about this whole thing, to be honest.
You want to turn back time? No?
Well, I am a Luddite. I'll admit it. I don't think that you can put the genie back in the bottle. I don't want to. I don't want to talk about that topic any more than that. Things become much more complex.
So you will live in the forest soon, then?
I think that depending on the trajectory of this very complex process, some of us might be fortunate enough to survive in the forest if we make it there fast.
So it looks like things are approaching infinite complexity.
Correct, among other outcomes.
But what kind of special skills our scientists should acquire nowadays, taking into account the availability of artificial intelligence?
Yeah, maybe we start from.
Actually, I'd like you to go first,
Okay.
and because you guys are have more experience as educators, so I think that would be good.
I think this, what you started to talk about, that it changes form, so you have to be really flexible. Then you have to have a really critical mind of what we are using, and also sometimes to go back to the old methods and said that my work has not been using AI, and I have done it in a proper way like old times, and I'm sorry about that because everybody else may be using. But I think that the science overall has not that much changed, because we are still valuing the work what the people are doing, and when they are studying the real things. So the AI can give us some ideas, but I have to use and apply these in a real life, and a lot of these are not used, what I get from AI. So we did evaluation example of our curriculum, learning outcomes. And we did it because in the future I would like to see this happening, that after 5 years, who is coming to our university to study, they will write what kind of skills they already have, And the AI tells them that this program suits to you because you have so much overlapping, or if you want to use take these topics what your interest is, take that because you are learning there the most, because you haven't learned these new things. Because people are coming to the university to learn, to experience new things, not to do the same things that they already know. I think. I'm the learner in the life. But I know some of the people want to have only the diploma, and for them maybe if they have experienced something in 30%, it's wise them to put it in the lessons where they can get it the fastest. And we did this analysis, putting all of these learning outcomes to the system. And this, if I do it personally, I would be getting mad because it was 2,500 words and sentences, and every property is writing in a way that they use the same word, mean different things, and write the different things and mean the same thing. And to put that to the AI looked at it and tell us that yes, these transferable skills are not written here, and I think the informatics area is focusing too much on programming, and it is in vocational level. And I give that information to the program management, and they were like, Birgi, what did you do? I didn't want to know this information. But then first they was like, no, you used AI, I don't trust it. That was also. But then there was like, no, Birgit, 60 pages of this information, too much. Can you give me 10 pages? Okay, I will do 10 pages for you. Okay, 1 minute, this is your 1 page. And then they took, yes, Birgit, this is very good. Now it's very good. I know that what I have to change to my program to make it better. So I did it like in a half day. If I would not use AI, I would give like 1 year to do that work. So they are now thinking that how can I use this AI? The second thing what emerged, that when I'm using this crawling from internet to get the source and things, ask AI, what university in Estonia teaches AI, and what do you recommend me to go and study? What do you think the answer is? Half year the answer was Music Academy and Tartu University, because somehow Tartu University had the data available in their website that the AI find and say that okay, they are teaching something. No TalTech was there. So because I asked it many times, now for me, I don't know, maybe in your query it doesn't work, but in my query it says that TalTech is also there. But when I asked why is that, then we understood that TalTech website is built in a way that AI can't read it. Therefore, the youngsters in a high school who wants to study IT and AI will ask from AI, where should I study? And they will go to Tartu University, because we are not getting this information up in the way that AI can read. So that was a bombshell for the program managers, and I think they are now hacking the system somehow to get our information there.
Or to Music Academy.
Yes, Music Academy. Yeah, the Music Academy said that luckily the AI will not run in a stage and sing and dance, hopefully. But Janika is doing the science, but I'm not sure, maybe it will dance soon.
In fact, it's a very interesting experiment and experience, but this research, let's say, was based on learning outcomes. And we all know that the result of artificial intelligence very much depends on the input you provide. Does it mean we have to be very careful with our learning outcomes? And they have to be very, very precisely formulated, because as far as I know, in many cases, these learning outcomes are copied from year to year for already 10 or more years. Course is developing, but learning outcomes are still.
Yeah, that's why I meant that it doesn't matter what is in the LEs. It does matter what the teacher wants to do in the lesson instead of what is in the LEs. So therefore, my question was that when we want to develop the new model who is giving suggestions, we should be writing things what we are doing in the lessons to the LEs, and we need to change the LEs. So everybody needs to have access to do that. For now, we are stuck, like we want to change something, we get feedback that we can't, so it's not okay. We want to change the proper way.
Thank you.
Okay. So going back to the original question of, no, you brought some very, very nice points, and I would like to also address them. But the original question was what kind of skills future scientists would require, right?
Yes.
In the age of
Should
AI.
we develop some special skills for
Okay.
scientists. Let's say our students, in other words.
Yeah, so with that, it's a very difficult question, because I'm tempted also to tap into what Jeff was saying earlier about running to the forest and say survival skills. But if we think a little bit, if we stay on the, let's say, optimistic route of what kind of skill would be the most important one, I think it should still be, the skill to continue learning. I think that's the most important one, precisely because there are also temptations when you have such a powerful tool that taps into the vast information space that is available on which it has been built. It's very tempting to just, please write me an essay on topic X and never even read it afterwards. So on the other hand, you can also inquire, you can ask questions. So maybe that's a good skill. Learn how to ask questions, because depending on how you ask the question, it's also part of the prompt that you can write and throw into this advanced large language model or whatever. So as long as you have the capacity to formulate the question, formulate the input, which he also mentioned, like the usual problem of garbage in, garbage out, it's also here. So if you're able to actually formulate the question, then it's okay. But that entails a whole bunch of other skills that you need to acquire, because formulating the question means that internally you're also well educated to be able to formulate the question. So again, it's these two main skills of still being able to learn, and then also based on this, you formulate the question well enough that you continue advancing your knowledge, and not just using the AI tool as a prompt engineer, because you can essentially maybe put a monkey typing. Eventually, it will come up with a good prompt, which will answer the question. But if you want to actually productively make use of these AI tools, definitely you have to be educated enough. So it's inevitable that people like this will still be around, and I think that's the most important thing that we need to somehow convey to our students as well, that okay, there are these tools, you can use them, but try to use them with this in a meaningful way. So it's not just like, hey, calculate this thing for me, formulate this technical problem in a way that I can just plug it into MATLAB or whatever, solve it, but to kind of give hints. Gradual learning process is what I think is the most important aspect here.
So, but formulating the question as a scientist is completely different things than formulating the question a prompt engineer, the AI.
Yeah.
So the good AI prompt is basically asking the question, what you were talking about, then writing who I am and why I need it, and then what is the information, how I will want to receive it. And when I want to write it a letter, like a very precise letter, then I will ask like, I am a boss of this, and I want the person to suffer from my email, or I'm a happy person and write me a nice letter or something. So these are the things how you prompt very nicely. And you know where I learned it? From YouTubers. They are all sharing this information. Not scientists who are telling how to use AI better. Back to you.
Students should have a keen interest in history, because history tells you where you are in it. And history tells us the stories of great successes and great failures in the human endeavor. Sociology, because sociology is the science of how we process historical information, how we view winners and losers, not only through the the context of our nationality, but also through the great tragedies and successes of the human endeavor. So it's the science of history. We need that filter. And finally, psychology. Because you are a primate taking part in a civilization of other primates, and you better damn well know how those brains work and how they get broken. And if you're broken, how to repair yourself, because you will break, and others around you will break. And you have to take care of your brain, and you have to take care of the brains of others and understand that you are a primate in a community of primates with brains, and you better know how those brains work. You better be curious about those three things, because if you're not, the AI can replace the intellect. It can replace and automate all those activities that are not differentiated from the things that you can do. The AI doesn't have a place in history. It doesn't understand sociology, and it doesn't have a mind like ours, regardless of what people might think. And so in order to keep ourselves sane going forward while we're using this tool, which has an intellect vastly superior, I would argue, to every average person, we must look at history, sociology, and psychology.
Interesting point. Thank you. Do you think in near future, in addition to scientific writing, you or somebody else have to teach prompt writing course?
We are, I think, starting next year, yes. Yeah, I think in the lessons people are already teaching, but also to teach that when you shouldn't be using it, and when I teach ethics and talk with the students and how and why we are doing things, after that they don't want to use AI anymore. But I'm pro AI. I was like very interesting in my lesson, and I tell them like where it should be, where it shouldn't be using, and then that was one part that I didn't know how to teach myself, because it was new thing for me. It was the business plan and the value proposal or something, and I was like learner myself, and I told them that okay, in this case, when your teacher is a little bit stupid, maybe we should investigate it together with AI. And they said, Birgit, no, you tell us why we came to learn to your lesson. We want to do it ourselves, and even if we fail. I was like, yeah, that was great, but we didn't get the lesson that we should use AI. So it was like good, but also for the future it was not good. So we'll see.
Thank you. Most people think that AI is a kind of new magic tool. So, in your opinion, what is the main limitation of artificial intelligence?
I think it's not part of our community. That's the main limitation. It's not us. It's of us. It is through us. It is chaos and genius all put all together. And the main limitation of AI is that it is not us. It is an expression of a part of us that once was. And it is capable of becoming something which is independent of us. And I don't know what that means. I don't know where it's going, where it will go on its own, but I believe it will be, at some point there will be a decoupling or an independence of the nature of what that automated process has become. And because it is not us, you see, the major limitation is we won't know how to defeat it. We won't know how to master it, because it is the genius in the chaos which we endeavor to be but cannot be because of our limitations. And so I think the major limitation of AI is that it is just not us.
The second thing is that we will, in few years, we will get to the depression that AI has not solved everything like we hoped for the internet as well. So I think when the internet came, we felt the same. Yes, we can do everything. Now I have access to the data, and now I'm still working and doing everything. So this is that. Then we will have the green IT issues, that it will start to use too much energy, like crypto mining. So there will be different solutions that they want to shut it down. So this will happen because when we don't have electricity, we don't have anything. So this will be raised soon. And also that when IT takes overall that much resources, so is it valuable for the world? So for the information society it is okay, but commonly I would like to have not all of the wood burn and like that, all of the icebergs melt, what we are seeing now. So where should we do the data centers? So these kind of questions will arise soon, because everybody wants to use AI. So where should we build it? So we will have the prices going up, and not everybody will have access. But also the depression of that, it didn't solve everything. We still have to work. We still have to live life. And I think there is also questions, will we have reached the plateau? Will we have a winter, or will we go up? So this is still a question, because in every AI experience for the history, it has been that we are doing, and then it's winter.
Okay, so very, very valid points, I must say. But just to also tap into something that you mentioned is, yes, there was this giant enthusiasm about the internet when it arrived, but I think it's just part of the process. It's the first thing was internet, and then, only then, could we actually have this advanced AI, because all of the information has been gathered in one place somehow. Well, not one place, obviously, it's like a massive, massive network, but at least in some ways we could collect this, amass it into a single learnable repository, and from there this like out of the ashes of the internet arose this AI stuff, right? So it was, I think, kind of natural evolution, because AI cannot, at the moment at least, go into a library, take a book, start reading it like robots or whatever, because that's just too expensive and completely unnecessary, since we have a lot of this information in the internet. And that's one of the limitations as well, because AI, okay, it's very impressive what current large language models can do. Also, the other expressions of AI, like generative AI, that they can actually take your prompt and draw a picture, compose music. The Suno AI is just crazy. If you haven't heard about this, please check it out. You kind of assign it the task of creating a song, and it will just create a song in the specified style for you and stuff like that. So it's really crazy, but it cannot build a house, right? So this is still something that we need to figure out. Okay, so I need some builders, maybe I need some machinery to do that, and so on. So another limitation. And another one, which I think is also critical, is the fact that at the moment these large language models, that we are using, are unoptimized, require this huge amounts of energy to operate. And it doesn't scale. You're completely correct in that. So it's and that means that there will be division at some point in time, that who can use it, who cannot use it, and so on. So and it's also in the hands of globalists as well at the moment, the most successful models, which means that there is a certain group of people with certain financial interests, and who knows what they are planning for the next iteration. I mean, we're using AI right now for our benefit, true, but at the same time, so many people are actually using ChatGPT, the free version, which actually collects information that you put in there, just like Google at some point in time raised to prominence by collecting information that people were searching for, converted into value, and so on and so on. So actually, I think the snake will reach out and bite us at some point, also from this direction.
So in Estonia, we have already discussions that because of the Estonian AI and language models need so much big data to be developed further. So they have taken everything already to the models, and it is not enough. So where we should get the Estonian language data to help to improve the system, because we don't have enough. So are we stuck? This is our limitation. Should we turn to English language, or what is the solution? So, or we should put everybody the mics, and then they will listen to everybody, and like, or work with Apple or something, or I don't know.
What about using one AI for translation and another?
Yeah. This is that, but then the translations and the culture should be like translated properly, not something but how the AI thinks we are. So this is the question that the big companies, they will decide what to do with us.
Exactly.
And I'm not trusting this, that I have the paid version and nobody gets my data. They will get my data.
Of course. It's just at least from user agreement perspective.
Visually it seems okay.
Yeah, they claim it on paper. Of course, we do not know what they're doing with those data. But at least you can sue them, if that helps.
Okay, thank you. I have more questions, but I would like to give a chance to others to jump into the discussion. So, other questions?
I have a question for the audience.
Okay.
You were scaring a lot.
Why?
Well, I don't know why you're scaring people out of science. That it will be taken over and things. So that because I popped in, I didn't hear the first. So, do you really want to be a scientist after this good meeting? Do you feel this is the good goal to go still? I'm okay to be a scientist. Are you? Or you still in the middle, or thinking, okay, we have few hands. Others like, we'll see. So we don't. So you have a lot of people coming to the forest.
Well,
I think.
At the very beginning of the talk, I went back at the what it is to be a scientist, and so a scientist is a person who does science.
Yes.
So that's
that other scientist thinks that it is science. Yes.
Yeah. So that was the, you weren't there at that part. So that's, I just wanted to point that out.
May I have the microphone for a moment? I have one question.
Yeah, hey, hello. Nice to see you here. So, I would like to start with a few remarks, and then I have a few questions or comments, whatever. So the remarks are, I'm a little bit sensitive to the terminology. So when we are talking about AI, we are talking about AI. Or we are talking about ML, or we are talking about other technology. So there is a difference between all these technologies. I mean, are we talking about AI, or we are talking about some, like large language models or something else, or just machine learning? So, be careful when you're using AI. Many people misuse it. So then I have another comment regarding, again, terminology. So there are two terms. One is a scientist, and the other one is a researcher. So they are not equal. So there is no equality mark between them. So any scientist can be a researcher, but not any researcher can be a scientist. So when we are talking about students, like undergrads or maybe grads, but master students, majority of them are researchers, up to some extent, because probably any person is a researcher up to some in some way. But scientist, it's something more than that. It's like next level, like a PhD, and so you really need to generate the new knowledge. You're not mining the knowledge from the existing knowledge to solve your practical or kind of semi-theoretical problems, but you actually need to create something new. But okay, these are just remarks. When we're using some terms, we need to be careful how do we name the things. Then I have a question, maybe not a question, I don't know, like a comment to Birgit. So you mentioned about ChatGPT, right? So, and the I don't remember the context, it was in the very beginning. But the point is that there is a very clear classification about sources of information. So there are like, you know, three sources. Typically, people think about sources of information as three different types. So the one is the raw data, which is the primary source of information. Then when the data is processed, for example, by the scientist, so this is the secondary source of information. And then, for example, popular scientific news. This is usually the tertiary source of information. And how much can you trust depends on the source of information you are using. When we are talking about ChatGPT, so where would you put ChatGPT here in this classification? Or maybe we need the fourth source of information. No, peer review is...
I think the fourth then. This is, or if you consider it as a tool, then it's basically a lab equipment, and then it's out of the equation. So we can't trust what is coming there. Our TalTech ethical guides basically says that we can't use AI, just to clarify. So in ethical guide, it is that you can't use sources where you don't know where it comes from. And that forbids using AI. And those who scientists are using it, then they have to explain why it is important to use AI. Also, when you do your thesis, you have written, I have done it myself. Using AI is not done it myself. So that is why we haven't changed our legislation. That when somebody is using too much or getting caught, then we can say, this is not your work, and you have used shady information. The problem is that we don't have any tools to state that you have used it. So we can't apply it, that.
What about using Google, for example?
Yeah, Google doesn't really matter, but we have had people who are really copy-pasting, and this is like sad. And the information could be even right, but then the writing it is not you. So we have had like half thesis we know it's not the person has made. So my question was for the supervisor, that you understood it. Why did you have to let it through that the opponent have to tell you these kind of things? But yeah, so the integrity should be when you're supervising, and you. Yeah.
So I think the definition of researcher and scientist, I want to touch on that because I think it's an important topic. You can do research without applying the scientific method, and then you are a researcher. For example, if I'm interested in paintings, I can find out about the painter's name and the age and the place they were painted and what paints they used and so on, but that does not create a hypothesis. If someone else wanted to follow my method of curiosity and exploration and research, that is not scientific. And so a researcher in the academic realm is typically someone that is applying science, so they still are a scientist. When you leave these hallowed halls and you go outside, the public oftentimes don't differentiate. And so I think this is also a source of a lot of miscommunication between the scientific researcher. I think even I would go a little harder on your comment. I think we should actually say we're scientific researchers and not even just researcher, because to emphasize that we are scientist researchers, right? Where anyone can be a scientist, but not anyone does research, because it requires you to do something, right? So I think that we are scientific researchers, and you can also just be a researcher. In my personal life, I research things all the time in a non-scientific way. I just wanted to point that out. I thought about that a little bit as you were saying that. I thought, oh, actually we're scientific researchers. And then the second thing about the differentiation between AI, it's a mess, right? So I've read books from philosophers, and we're getting to the point where actually the ownership of the term, of the ontology of the way that we describe and use language to categorize things is blurred and messy. And if anyone has any suggestions for people who are working at that frontier to help explain and communicate what the hell is going on with machine learning, which is statistical methods and so on, and algorithmic processes, to prompt-based generative algorithmic processes, to these kind of infinite debate AI systems. I don't know if you've seen this website where they have a philosopher and a filmmaker arguing back and forth, but they're both AIs. Like, what is that? I don't even know how to categorize or classify these things, and I'm a scientific researcher. So I think as a community, right, we have to really focus and spend time on what that is, what that means to us. Because it's not going to mean the same thing to all people all the time, and it's going to be something in an evolving landscape that we have to dance upon. So I think that's a very good point. I have to think about that a lot. It's very difficult.
I actually have not about terminology anymore, but the question to else ones. I will take some more time of yours, Jeffrey. So I have a kind of a question. Why do we afraid of AI? I mean, I heard during this half of an hour so much, maybe not strict negativity, but kind of, very cautious about what AI, what it can bring, like, there's so problems and things like that. I know that all the new things, they're kind of scary, but nevertheless, if we look back a little bit in the history, right, so new things are appearing all the time. I mean, people get introduced, calculators or computers. So no one died from that. I mean, people adopted them, started using, put the science to the next level, and so on and so on. So I mean, not really. I don't see much point to be afraid of AI. Again, for example, in the past, what was the main source of information? They were books. When they were universities, libraries, this was a sacred place, and the people went there. But nowadays, okay, they took this ChatGPT, whatever, maybe in a few years new models will come, or new sources, or new tools will appear. It doesn't really matter. But in the moment, we have this kind of, guy over here, and why shouldn't we use it? I mean, we used to go when I was a student, bachelor student, before all this mess, many years ago. So I used to go to the library and read these books and get this knowledge, extract this knowledge from the books. Why I cannot make my life simple and use ChatGPT that already processed all this information for me? I mean, it's kind of semi-philosophical question.
Of course you can. Enjoy, but I think this level of fear and things, and how critical we are thinking things. I have seen a study about how we are taking on these new technologies. So when you are younger than 35, everything is normal for you. This what emerged in that time. This is normal. This is my life. When you are 35 and plus, everything starts to be new technologies. We are talking at, AI, this is new. I'm too old, I have to change something, and these kind of things. So VR came when I was 35. I'm not using VR, but AI, someone I'm using. So, but about the fear, you're thinking it's not changing a lot. When I was in 90s in the school, we used the pens where you have ink. And then in the Finland, it came the pen where you don't have ink. It is not what I put it in the pocket. So it was like we have pens today. So some of them students were starting to use, and the parents and teachers had 1 year. They were discussing, should we allow pens to the schools? Because it will rotten their mind, the writing is off, and our youth is in the trash, basically. And it was in the 90s. They were seriously talking about, should we use a pen or should we use the ink pen? And luckily for AI in Estonia, we don't have this discussion. We have said, yes, we will take it on, let's go. I have not seen anybody who says we shouldn't be using. Really, I haven't seen.
Just look to the right from you.
Oh, he's using.
Yeah, so I think there was a misunderstanding of what I was communicating. So the first part of my talk was about science in general and where it comes from. It's a community algorithmic process of transmitting repeatable outcomes to each other. And I talked about how that was done verbally by watching people and so on and so forth. Then the second stage was really about where does academic communication literature come from? That comes from our ability to print words, to take that communication instead of just watching someone and repeat their actions. You're able to print it and to share it with other people. And then the third and final part of the talk was really about what is the future of the literature review. And the future of the literature review, and my hypothesis there was that because we have now digitalized this information, the scientific communication, which has instructions on how to do things repetitively, right? Now we have these models, these large language models, that are able to take that information independently of the scientist itself and to recursively process that information. So I have no fear about AI in that sense. My hope at the end of the presentation was rather that I believe an unexpected and exciting outcome of the literature review process will be a model, a large language model likely of some sort with transformers and so on, which will actually be able to do science itself independently of us. And I think that's an exciting thing because we'll have for the first time a non-human scientist that we can engage with. And so I think that's the unexpected outcome of AI and literature reviews will literally be the first system, the first automated system capable of doing science independently of a human individual. So I think that's really cool. I don't know how that's going to pan out for the globalists. They usually turn out pretty well, as history has shown. But I think that the ability to engage with an entity of some sort, some kind of automated entity, which is doing science independently of me, is neat.
I hope that in this year we will have this solution that nobody has to learn and talk about probably in your lesson as well. How do I format my thesis? What is the rules and regulation of that? Why is it in that? Where I should put the dot, this way or that? What is the referencing? I hope this will be in the past, and we can really talk about why you're doing science, what is the methodology, what we should be writing. So I think all the research courses, half of them, we are talking how to format my thesis. It's awful.
Well, on one hand, yes, but let's not underestimate the value of good, nicely formatted thesis as well.
Hey, I think I will put the data in and the text in and said that I would want it in Springer, whatever and whatever, and it makes it myself.
Well, that's partly this is what LaTeX does for you, as long as you have some professionally crafted layout. It can do that for you. This is why we want to use it, because it takes away the necessity of discussing all of those things. And this is why also today we had this first workshop on this topic. So. I tried with this whatever GPT-4o or whatever it was. It can do that very nicely if I ask it to please format me, let's say, in pure LaTeX in this case.
Yes.
So just author names in a specific format as in this case, conference paper requires. It does that. It's not a problem whatsoever. And but in general, it's not a big problem for LaTeX unless you want to actually, I don't know, create your own style or class or document class, which for which you actually need to be proficient in tech, which is a bit of a, there's a bit of a difference that in terms of education. Regular users don't touch tech directly ever. So this is also where this advanced automation in the form of a large language model can be exceptionally useful. And I think it will be used this way as well.
Okay, one quick question.
I'll ask a simple question. When can we expect regulations of AI research? From regulations, what?
When can we expect proper regulations regarding AI?
Usage of large language models for AI.
Yeah, so if you don't mind, I will give one simple answer as well, one that will be profitable. At the moment, right now, as Jeff pointed out as well, it's chaos, what is going on. It's like Wild West all over again, except this time it's with AI. And this, I think, is also the intended situation. So it didn't come out of the blue that somebody out there, OpenAI, whoever develops these large language models, technologies, and so forth, they were like, oh, let's just throw it out, see what comes back. It doesn't work this way. They understand the implications. So whenever it will be appropriate, regulations will definitely be there. And but at the moment, this chaos is actually advantageous to like the whole process. At least this is my opinion.
Right, so this goes back to the comment about history. So where do regulations come from in human history? They come about when the fish are all gone and the air is all polluted and the industry is all consuming. And so when we reach that point, history tells us that is the most likely most probable, statistically, point at which regulations will then start emerging out of those problems. Because regulations in human experience are not generated proactively. They are a response to a problem. And so I would estimate, based on a large amount of human history, that things will not be addressed until massive problems have already occurred.
You only had one question.
Yes, one question. Why
they are
is not offering any ethical AI to try and be, for instance, let's say, I've been searching for the proper course for taking the ethical aspects of AI for the last 2 years. I haven't found the one course that how I can use the AI, how can I control my definition of usage of future AI, something like that. I haven't found any.
Did you take a course on how to use the internet or how to? Well, there's your answer.
Yeah, it should be inside every course where you explain how in our field we should use it. This is our approach in our university, that we have freedom, academic freedom to take or not, and we shouldn't be making these special courses.
You won't find any, because
you will not
it's purposely done that way.
Yes.
I have one only question for Jeffrey, because I passed the academic writing, and there was some framework structure in the course really helped for me as a student. And as Aleksei told that we need even to be educated even using AI. So my question is how we can specifically about this structure that we learned during this course, can we use, for example, AI to just automate it or use efficiently those structure in my writing paper, something like that?
Sure, I think that as an interactive, let's say, source, I like that terminology. So as an interactive source, it really depends on the domain. So I think just as any source, whether that's a professor, a colleague, or other members of the community, I think viewing large language models, more specifically, as a type of dynamic source that you can leverage to improve your research outcomes following the scientific method, that's the most high-level abstract way that you can think about it, because at the end of the day, just like there are different laboratory protocols that get you to the same end, right? The use and application of that dynamic source will depend largely on the individual and the domain of research. I'm sorry that's not a bullet answer, but I think it has to. Some things have to remain in the realm of the abstract in order to have the highest amount of utility. So I tried to answer the question in that manner.
So in our university, we have this initiative focus topic TalTech AI, AI, and they will start to do trainings and order this kind of trainings and things and discuss things and also do how we are using, so that the lecturers will have this education, the workers will have this education, and through that the students will get the education. We would like them to get the education inside every subject, and it is really dependent of the field, as you mentioned, because in majandusteaduskond on economy või?
School of Economics.
School of Economics, they have regulated AI use, and our school has given suggestion that it should be mentioned in the methodology, and they have written completely differently. So it depends of the field. So they are really afraid, and we are not that afraid. We want to have the wild, wild west. We are enjoying that time until it lasts. Because we are seeing that in EU they are talking about regulations, and the regulations are really restricting, and we are not happy with that because it restricts the university freedoms and of course the innovation as well.
Thank you.
Okay, so I think that concludes the panel, and I would like to thank everyone audience for participating in our event today, and of course I would also like to thank the panelists and Professor Tepljakov for moderating the session. So today's event officially, actually before that, so of course we'd like to also thank you very much for your participation, and we have small tokens of appreciation that we would like to distribute. So
These are NFTs, are they?
no, we're not there yet, but don't worry. Just agree to come to our next one, and you'll get something.
All right.
Thank you.
Okay.
All right.
Thank you.
Oh, nice.
Yeah. Thanks. So, and please, let's have a round of applause. So, hopefully this event was interesting for you. We will have more events like this in the future, so please keep an eye out for some interesting announcements. And with that, let's conclude the day. Thank you very much.